Hello everyone and welcome to today's session on MLOps. Do you know friends that the market for MLOps solution is expected to reach $4 billion by 2025? We are in very early days, but the strategy to adopt MLOps will take shape over the next few years. Watch this video till the end to learn about the MLOps. Now before we discuss our today's agenda, do not forget to hit the subscribe button and click the bell icon. So first, let's discuss our agenda. So first, we will discuss about introduction to cloud service. Moving ahead, we will discuss about transformation from traditional way to the cloud platform. And then we will study about what is virtualization and creating VMs. Moving ahead, we will discuss about what is MLOps and process of MLOps. Then we will understand about ML pipelines. Moving ahead, then we are going to discuss about what is hyperparameters tuning. Then we will deep dive into creating resource group and storage account. Moving ahead, we are going to discuss about creating Azure machine learning workspace. Then we will learn about creating Azure ML pipelines using notebook. Moving ahead, we are going to discuss creating Azure ML pipelines using designer option. And then we will discuss about difference between creating ML pipelines using designer option and notebook. And at the end, we are going to have a good hands-on session.
First of all, let me just go ahead and check where do we stand, all of us, where do we stand with respect to basic cloud computing idea and as well as with respect to Azure. So I'll be asking you a couple of questions from an Azure perspective as well as from a cloud computing perspective so that I can align with you regarding from where exactly I have to start and what I need to talk about today. Okay, so just wanted to get a clarity on that. So I'll be giving or I'll be asking a few questions with respect to understanding where do we all stand. Okay, so let me ask you this. Per your understanding, what is cloud computing? When you hear the word cloud computing, what is your understanding, right? What exactly you understand by it when somebody says, okay, cloud computing, right? Just let me know in the chat, whatever you understand it, the way you have understood, just put it on the chat so that let me just validate where do we stand exactly with respect to cloud computing knowledge. Virtual computing, storage, okay. Any other responses? High processing and computing ability, storing all the information to server, store data on online platform with SaaS, which provide all type of SaaS, managing resources on the cloud, computing services available on the internet, access from anywhere, cloud storage system. Any other answers? A simple short definition for cloud computing: deploying your own virtual machine, managing resource in cloud, using a cloud network as a platform to compute multiple services. Okay, so actually all of these answers which I'm getting over here are in fact either some part of the answer or something related to it. Okay, and there are some mistakes as well. So let's just have a clarity on this part first of all. So maybe we can just start with what exactly cloud computing is all about. Okay, so that would be the best start I'll be planning to do right now. Okay, so let's just talk about what exactly is cloud computing, how did we reach here, and then what is Azure. A small introduction to Azure also we can do, and then probably that will be giving an idea what is meant by cloud computing in the first place. Okay, fair enough. So now all of you listen carefully what exactly we are explaining over here. In case if you have any doubts or anything, you can ask me once after we have done with the explanation. You can just put the questions on the Q&A. Also, you can make notes, have a book or pen ready with you. Just make notes, whatever you want to take a note of. Okay, you can also use a notepad as well, but taking it with a pen and paper would be more ideal rather than writing on the laptop. Anyway, so let me just take you to the whiteboard. Okay, so there we go. So introduction to cloud, that's what we have, right? Introduction to cloud computing. In case if you have any difficulty reading what I have written here, please ask. Introduction to cloud. Okay, and then after we complete this introduction to cloud, we will move on to what is Azure as well. Okay, so introduction to cloud. So first of all, before even talking about cloud computing, one thing that you have to understand is a IT infrastructure. A traditional IT infrastructure means what? First of all, from a company's perspective, what is meant by a IT infrastructure? An IT infrastructure means Whenever a company has certain requirements, for example, hosting a website, or they want to install certain applications, maybe they have to set up some database, SQL, right? So all this kind of things, if you have to do for a IT company, they require servers now, right? They require something called as servers. What exactly servers? We do have personal computers like laptop and desktop. Above this personal laptop, personal desktops, we have a certain compute category, and that's what we call as servers. Servers are designed for running 24 bar 7, 24 bar 7 bar 365. Very powerful devices, very powerful devices used for very high compute calculations and all that, with very high processing power, with very high RAM capacity, and so on and so forth, right? That's what we call as a server. These servers will have their own operating system. For example, on a personal computer, on a desktop, laptop, we install and use Windows 7, Windows 8.1 kind of operating system, which we call as a client operating system, right? A client operating system. So these client operating systems are for our personal use cases. But for example, as I told you, for hosting a website, for setting up a application and so on, you will need dedicated operating systems, which we call as server operating system. So from Microsoft, we have server operating system like Windows Server. Windows Server. What are the versions, guys? Probably most of you would be aware of it. Windows Server, we have the most recent one, Windows Server 2022. You have 2019 previous to this, 2016 we have, 2012 we have, and so on and so forth, right? From a Linux platform, you have, for example, Red Hat Enterprise Linux, currently 8 or 9 version we have. And then we have, for example, your what we call CentOS, Ubuntu servers, right? So all this kind of servers also we do have from a Linux perspective. I don't have to explain you this. Probably most of you will be aware of the different server operating systems and so on, right? So we understood a server computer we have much more powerful than personal computers, right? What is the spelling for second one? Windows Server. This is WINDOWS SERVERS. Okay, SERVERS servers 2022, 19, 16, 2012. This is RHEL. This is CENTOS, CentOS. This is UBUNTU, Ubuntu servers, right? These are the various servers that is available for you. Okay, this is CentOS. Okay, so I think that is clear now. So we understood, okay, we do have operating systems, right? Operating systems called as server operating systems, which will be installed on powerful servers for various organizational needs. Okay, so any company, if they need to have, or if they need, for example, database to be set up, applications to be set up, in such cases and all, they will be going with this server hardware and server operating system. Is there anybody who has not seen a server hardware? Anyone here who has not seen a server hardware? Just let me know in the chat. Anyone who has not seen a physical server hardware? Okay, so let me quickly show you that as well. So if I just go back to the browser, you can see here, for example, server hardware, for example. Remember, there are OEMs in the sense original equipment manufacturer who are making these servers. Namely, we have HP, we have Dell, we have Lenovo, we have IBM, all these different companies making servers. The most prominent ones of them are your HP and Dell. And these HP servers will be typically called as Proliant series, PROLIANT, and Dell series servers will be called as Power Edge series servers. For example, if you type over here, HP Proliant DL380 Gen 9, for example. Okay, DL380 is actually a model number. And if you go to images, you will be able to see the HP servers, right? You can see below. This is what a server will be looking like. HP Proliant DL380 Gen 9 server it is, right? So you can see this is a bulky, computer device. We can say it's not like your personal computer. It's not like a laptop. It's a kind of a bulky device that you have over here. Okay, and these are very powerful. In fact, they have a lot of capabilities built into them, and that is a whole discussion separately altogether. Now in this servers itself, in fact, there are three different types of servers. We call them as rack rack server versus blade server versus tower server. Three different categories of servers we do have. And if you want to see them separately, you can see there is one diagram. Let me show you, which will depict all three exactly with all the differences. Where it is. Rack server versus blade server versus tower server. Yeah, here we go. So you can see here on the right hand side. So you can see out of this three, the first one is what we call as a rack server. The first one is what we call as a rack server. Middle one, something similar to your normal desktop, right? That is what we call as a tower server. And then on the right hand side, what you have is actually called as a blade server. So what you see, this larger box is actually a blade chassis, a blade chassis. And within that blade chassis, you have so many blades in the sense, each of the blade will be individual server. So for example, this is one server, another one, third one, fourth one, and so on. You have so many servers included in a single chassis, right? So this is what we have, three different types of servers that is available for us. If you look at this guy on the right hand side, now you can see he's actually pulling out one server from the chassis. One blade he's actually pulling out from the servers. Now all the servers will be mounted onto something called as a rack. Mounted onto something called as a rack. You can see, in fact, on the right hand side now is actually a rack that you're seeing over here. A rack is a tall structure in which you will be mounting all the servers. For example, you can see there are other pictures as well of a rack and servers inside it. Okay, these are server racks and servers mounted onto them. Okay, now in case if you wanted to see a enlarged picture of it, let me show you uh, data center. Data center. So if you go into a data center, you can see a data center is actually full of racks. There are so many racks available and there are so many servers available on each of these racks. You can see this are your cloud data centers and all that you're seeing currently on the screen, right? So data center is actually a building which is hosting all your physical servers, all other network equipments, all other hardwares required for your IT infrastructure, including all the cabling with cooling facility, with power backup facility, with adequate network connectivity. Such a building is what we call as data center. Okay, so most of the companies who do have servers and all, they will be having data centers available with them. Okay, fair enough. So now let's come back. So we understood we have physical servers and we understood the categories of it, like rack servers, tower servers, and blade servers. And we said these will be mounted onto a rack, and all these racks will be kept in a building, a specific room, which we call as a data center, right? So this is what we have with respect to, a data center. Now I told you about a cooling facility within the data center. Why do we need this cooling facility in the data center? Why we need air conditioning in a data center? Any guess? Anyone? Why exactly you need cooling facility or air conditioning facility in a data center? Due to heating, right? We need to control the temperature in the room. So what happens, we know when we use the mobile phones itself, a simple mobile phone that you have itself can produce a good amount of heat, right? So now when we have this kind of powerful devices, that too, they are running 24/7 365. Of course, they produces a lot of heat. So which means we have to have some sort of control mechanism with which this heat can be controlled and it has to be cooled down. So that is why, if at all in your life, if you have visited a data center, or when you visit next time, just see a data center building will be always kept cool. Any of you have gone to data center can confirm it, right? It will be always kept cool. Inside that, if you go, they will always try to keep it cool with multiple air conditioners and so on, so that these devices doesn't get overheated and they don't burn, right? They don't burn. So this is what we have with respect to a data center building now. Perfect. So now we understood what is an IT infrastructure. An IT infrastructure typically consists of all this hardware which we just explained, kept in a data center, and much more. Okay, so whenever a company is having a requirement to, for example, hosting a website, or deploying applications, making web applications, and so on and so forth, they will be having this infrastructure. So now every company had their own infrastructure in the older days. Every company had their own infrastructures in the older days. Now, think of it. For example, you have a company or Shadil has a company. So now when we have this company, I do have a IT infrastructure set up on my own. Like I do have my own data centers, my own physical servers, and so on and so forth. How much investment approximately I would need in order to set up such an environment? Any guess? How much investment approximately I would need? Will it be, some small amount, maybe in couple of lakhs, or maybe in crore or billions, millions, right? How much I would need? Just take a guess. Okay. So of course you need a larger sum. You need a very large amount, especially it depends on the company as well. Like for example, if they are going for a smaller environment, yes, there will be a variation, but still you require a large amount of money with respect to setting up an IT infrastructure, which means there is a big factor involved whenever you set up the infrastructure, and that is most importantly the cost. Okay, a lot of money you will need initially in order to set up an infrastructure such as what we have seen, and then to maintain them you will have a lot of cost involved for it. Okay, so this is the first thing that you have to understand with a traditional IT infrastructure. I'm trying to explain you the reason why companies are moving away from traditional computing environment to something called as cloud computing and so on. Okay, so the first factor that we have is cost. Now along with this cost part, you have something called as maintenance. Okay, maintenance. What happens with maintenance? With respect to maintenance, now you can see there are two types of maintenance coming into the picture right now. Maintenance of the physical equipments, including your electricity, your air conditioning, and all this. When I say physical equipments, the maintenance of the hardware, right? For example, you might be having the server hardware, the racks, there might be switches. There is a device called as switches, right? Some of you might be aware of it. So there is a switching device from Cisco and all that, or there might be your other networking devices. So all of these things needs to be maintained. Plus, when we have servers, servers will contain the operating system. Servers will contain the operating system. So now on the operating system level, also you have the maintenance. So two types of maintenance. One is physical hardware maintenance. Another one is your software level maintenance. So both of this needs to be taken care of, right? Now for each of this respective skilled people you would need. For example, for hardware maintenance, you would need people who have skills on that particular area. For software level maintenance, you will need people who have expertise in that area, right? So now if you think of the expenses to them as well, you can see this maintenance is also costing us a lot. Maintaining such a huge infrastructure is a pain in the neck, by the way, right? So that is another factor that we have with respect to a traditional IT infrastructure. Then there is another aspect of it, something which we call as scalability. Scalability means what? Scalability means your ability to scale. Ability to scale means, like for example, let's say Shadil has a company and this company has deployed an e-commerce website. Just to take an example, we have deployed an e-commerce website. So when we have this e-commerce website, let's say one random day I decided to go for end of recent sale, right? Just like Mindra does. So now I'm on an end of recent sale, and what happens? There will be more number of people coming onto my applications than usual. More and more people will be coming onto my application. What happens when more number of people are coming? More number of requests will come to my servers. So when more number of requests is coming onto my servers, of course, the CPU utilization, the RAM utilization, etc., on the machine will be increasing exponentially, right? The requirement, hardware requirement, the CPU, RAM, etc., will increase now. You need more and more CPU and RAM. But every physical hardware will have certain limit with it. Every physical hardware will have certain limit with it. And now within that limit, what happens is now when you have this kind of sale going on, you will not be able to go and scale the infrastructure easily. You will not be able to scale the infrastructure easily now. because on an on-premises environment, we have a certain hardware available. And beyond that, if you want to go, if you want high capacity hardware and all, you would need to procure them in advance, have them configured, only then you will be able to use them. So within 1 or 2 clicks, in a few minutes time, or in maybe 1 or 2 hours, you will not be able to scale to a higher capacity servers and all on a on-premises environment. So that is another problem that we had with respect to traditional IT infrastructure. Anyway, so now we have a basic idea what are the problems that we had with respect to cloud computing, sorry, with respect to your traditional infrastructure. Cost wise, the problem, maintenance problem, and the scalability problem, we have explained all three. Okay, hope I'm making sense to all of you. Okay, now you can also see this cost can be classified into two different aspects. Now this cost can be classified into two different aspects. You have something called as capex, CAPEX, and then OPEX. Okay, OPEX. Okay, and now you can see capex and OPEX means what? Capex means capital expenditure, and OPEX means operational expenditure. Okay, what is the difference between the two, capex and OPEX? Capex is actually the capital that you invest into setting up all this infrastructure, and OPEX, operational expenditure, is the monthly cost, like recurring cost that you will be having. For example, the salary that you will be paying to the employees, any bills that you are paying continuously, etc. All this will be your OPEX. So all this capex and opex both are applicable in a traditional computing infrastructure. Okay, remember that particular point as well. One rack server contains Windows Server 2012, another rack contains Windows Server 2022. Can we merge both both of these Windows servers? You cannot merge as such. Physical servers, physical hardwares cannot be merged. You have to actually go with a different concept altogether, and that is what we are going on to next. Okay, okay, so that's it. Moving on. Now that we are clear with respect to on-premises IT infrastructure and what exactly happens over there, let's move on to how did the IT industry address this problem. We discussed about three problems, mainly cost, maintenance, and scalability. So to address this problem, now there came in one solution. One solution in the sense is it was not a solution for all the problems that we had, but it was some at least addressing some of it. Even though it is not addressing everything, at least some of these concerns were addressed when a new technology emerged. And that technology is something what we call as, anybody heard about this? Virtualization. Anybody heard about this technology called as virtualization? Anyone? Anyone heard about this technology called as virtualization? Okay, some of you have heard about it and familiar with the VM, not sure what it does. Virtual desktop, okay. Some of you are aware, some of you are not. So let me quickly explain what exactly virtualization is. Okay. In fact, this is the base of cloud computing. The entire cloud computing is actually built on top of this virtualization. Remember, that is the most important thing. Virtualization is the base of cloud computing. If virtualization concept was not there, then cloud computing will not be there, right? The whole cloud computing, let it be AWS, let it be GCP, let it be Azure, let it be Oracle, IBM, all these companies have built their cloud computing platforms on top of this technology, on top of this technology called as virtualization. That is what it is. It's a very important technology that we have here that we are just focusing right now. So now I told you, from a traditional infrastructure, when virtualization emerged, companies started moving on to this. Those people who have couple of years experience here, like maybe 10 years, 5 years, 10 years experience, they will not be able to see some 10 years experience and all. If you have, you would have seen that transition wherein companies started moving on to something called as a virtualized infrastructure. Okay, so what happens with respect to virtualization? So the company called as VMware, they introduced this concept commercially first of all, and they had their platform wherein you could virtualize a physical hardware. What is meant by virtualizing a physical hardware? So typically on a traditional IT infrastructure, what did we used to do is you will have a physical server bought. Like for example, I showed you a couple of minutes ago, the Dell PowerEdge server or HP Proliant server. So this kind of box or server you will buy, and directly on top of that server, you will install the operating system, and then you will just use it. I mean, in a normal scenario, you will be having a operating system sitting on top of this, right? Let me show you. So here you will be having an operating system, like for example, a Windows server or something. Just like in your personal computers and all, we have a hardware on top of which we have an operating system. The same way, physical servers also, they were having directly operating system on top of it. And then you will go and set up something on top of it. Like for example, maybe one server dedicated for SQL, one single server dedicated for SQL, another server for app service. For example, if you want to deploy any applications, then in that case, you will use another server directly, one single server dedicated for one specific purpose. So this is how we used it in the older scenario, in a traditional computing scenario. Now, here what happens is, when you have virtualization in place, instead of directly installing a Windows Server operating system on top of it, you will go and buy a powerful physical server. A powerful physical server. Instead of going ahead with a normal low capacity server, you will go and buy a powerful physical server. And on top of that powerful physical server, now what you are installing is not directly a Windows Server or Linux operating system, but rather you will install something called as a hypervisor. What is that? A hypervisor software. Let me just write it over here. A hypervisor software, Hypervisor. A hypervisor software you will go and install on top of the physical hardware. Okay, this physical hardware is what we call as bare metal. Sometimes you might have heard about this term bare metal. A bare metal means just a physical hardware as you bought it. It does not contain any operating system. Then on this bare metal, you are now installing something called as a hypervisor software. Okay, so VMware actually made a hypervisor software known as ESXi. ESXi. There are so many other examples for hypervisor softwares. Can anyone let me know some other examples of hypervisor software? Anybody who's familiar with these terms? Another example for hypervisor? Anyone? Examples of hypervisor? Hyper-V is actually a hypervisor software coming from Microsoft. KVM, that's a hypervisor software coming from Linux. VMware is actually a company name. Don't say VMware. VMware has products, and one of them is ESXi. Okay, and another VMware product is VMware Workstation. At least some of you might have used it personally, VMware Workstation. Then there is your Oracle VirtualBox. Don't say Oracle. Oracle again is a company name. Oracle VirtualBox we have, right? And these are all the things that we have with respect to, various hypervisor software. Okay, fair enough. There is a possibility that I missed the questions. So now that I have seen your question, let me respond to it. What is bare metal? Bare metal means, for example, you are buying a laptop. You are buying a laptop. Let's assume that laptop does not contain an operating system. There is no operating system. There is no Windows 10, nothing. Okay. In that case, it's just a metal box. Metal box in the sense you have the physical hardware and that's it. Which means what? That is what we call as a bare metal. It does not contain any operating system inside it. Such a server is what we call as bare metal. So even if it is your laptop who does not contain any operating system, we may call it as a bare metal. Does that make sense, Pratish? Okay. Another question, what is Citrix? Citrix is also a company. From Citrix, you have a product called as Citrix Xen Server, Xen. So you should say Citrix Xen instead of only saying Citrix. Citrix is the company name, just like I told you, VMware. When somebody is asking you what is a hypervisor software, you don't say Microsoft. You say Microsoft Hyper-V. That is the hypervisor software. Or somebody is asking, okay, another example for hypervisor software, you don't say VMware. You say VMware ESXi. Or you say, for example, Citrix Xen Server, Oracle VirtualBox, right? Linux KVM. These are the examples for hypervisor softwares. So what I do here is, on a physical hardware, on top of it now, I'll be installing a ESXi, or it might be a Hyper-V, or it might be, for example, any other supported virtualization software or hypervisor softwares. Okay, so I will have it installed on top of a bare metal hardware now. Linux means what? Linux is actually, there are two types of operating systems basically. One is called as Linux and one is called as Windows. For example, this Microsoft being a company, they have released an operating system for this server hardware, and that is what we call as a Windows Server operating system. So now Windows Server operating system is privately held. It is owned by one company. So there came in a new project by Linus Torvalds, and then uh, there was Larry Page or somebody, not Larry Page. There was one more guy. So these two people, they went ahead and set up a open source platform, which actually gave birth to a GNU project. And as part of this GNU project, now you have something called as a Linux operating system. So from the very beginning, this Linux is actually a rival to Windows Server operating system. This is an open source software that is available for you, which can run on servers. It is also a server operating system. It does have client operating systems as well. Okay, so that is what we have with respect to Windows and Linux. One question here, hypervisor software, does it replace the traditional operating systems? It does not replace the traditional operating system. We are explaining it yet. So listen, you will get a clarity shortly. So now here, what happened on top of the hypervisor software now, once we install this hypervisor software on a physical hardware, now we can say the server is actually virtualized. The server is virtualized. Remember,
Just a quick info, guys. If you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
there are certain conditions as well. This hardware should support this technology called as virtualization. If the underlying hardware does not support the technology called as virtualization, then in that case, it wouldn't work. Okay, that technology, to be more specific, it is something called as Intel VTX. Intel VTX. This is the technology. So your processor should support this Intel VTX technology. In that case, yes, you can go ahead and enable virtualization on this particular hardware. But remember, nowadays hardware, 100% of the new hardware does have built-in support for virtualization. All the CPUs that is getting released as of today do have support for something called as virtualization, so you don't have to worry about it. Okay, fair enough. So now that we have set up this hypervisor software, now what we actually can do is you can set up something called as virtual machines on top of it. Now on the physical hardware, I will be able to set up something called as virtual machines, VMs, in short, VMs. So far what we have is physical machine. Now we are creating something virtual. What happens with virtual? So now we know this physical or hardware over here, he does have certain capacity with it. For example, I told you you're buying a powerful server. You're buying, for example, a server with 64 GB RAM capacity, 64 GB RAM capacity. You have, for example, 16 core CPU, 16 core CPU, and maybe some 2 TB of storage capacity is also available. This is not a very powerful server, but I'm just taking an example for you to understand easily. 64 GB RAM capacity is available. 16 core CPU, 2 TB hard disk capacity is also available for me. So when I create virtual machines on top of it, now what happens is these virtual machines will be able to utilize this underlying physical hardware, which means whatever the total capacity that is available for you here, you will share it on this VMs. For example, on one of this VM, I can give, let's say, for example, 16 GB RAM capacity I'm giving for first VM. I'm giving some 2 core CPU to it. And then also I'm giving some 200 GB of storage capacity. For the second VM also I'm giving, for example, some 20 GB RAM capacity, 20 GB RAM capacity, and 2 core CPU, or maybe instead of 2 core, I'll just make it as 8 core CPU. And then I'm giving some 500 GB storage capacity as well. And so on, I can give on another machine as well, some 10 GB RAM capacity. Okay, maybe 2 core CPU, and some 100 GB storage. 100 GB is not enough, 200 GB storage capacity, and so on. Okay, so what we are doing here, according to your requirement, for example, for some of the reason you wanted through different servers on your company, for one for setting up your SQL, one for setting up your file server, another one for setting up your application. So in this way, if you wanted 3 VMs, now instead of buying 3 different physical hardware, I could go out and buy one single powerful physical hardware, and then I can create virtual machines on top of them. I can create virtual machines on top of them. Now you can see, for example, here we have configured 3 VMs. It doesn't necessarily mean you can only configure 3 or you have to configure 3. Depending upon the hardware capacity that is available for you, you can start from 1 and you can go up to any number till you reach the maximum capacity utilization on the underlying physical hardware. But let me ask you one question. So these VMs, you can see, for the first VM we have given 16 GB RAM capacity, second one we have given 20 GB, and third one we have given 10 GB. So total 20 plus 10, 30, 40, 46 GB RAM capacity you have utilized. 2 plus 8, that is actually 10, plus 2, 12 core CPU you have utilized. 200 plus 200 plus 500, 900 GB of storage capacity also you have utilized. Let me ask you, can you go beyond this capacity? I mean, you're creating additional VMs, and when you create this additional VMs and all, can you go beyond this base hardware capacity? Will it be possible? Can you go beyond the total capacity that is available on the underlying physical hardware? Yes or no? Logically think of it. Okay, so the answer for that is actually no. Why? Because when all these VMs are running together, for example, you have 3 VMs right now. So when all the 3 VMs are running, total utilization on the underlying physical hardware will be taken from this guy only. Because whenever you give capacity to this virtual machine, that is going from here, from the underlying physical hardware, which means right now we have utilized somewhere about 46 GB already. 46 GB RAM we have utilized. So which means whatever remaining, only them you will be able to use if you are creating additional VMs. So let's say, for example, you have 5 VMs, and 5 VMs altogether, they're utilizing the complete capacity, which means you cannot go beyond that. You cannot go beyond the total capacity that is available on the underlying physical hardware. But point here is, on a single hardware, now with the help of virtualization, I'm able to create multiple virtual machines. Each of them act like separate physical servers itself. One of the VM doesn't know about the existence of the other VM. So each of them are isolated, separate servers, which can be used now for your various use cases. So on the first VM, for example, I can go ahead and set up SQL. On the second VM, I can deploy my application. On the third VM, I can go ahead and deploy a file server, and so on and so forth. I can use them for various requirements. So this is the idea of virtualization. By virtualizing underlying physical hardware, you will be able to create multiple virtual machines on top of the physical server, right? There is a lot of other benefits as well, which we'll explain as we go forward. But first of all, let me ask you, are we clear with respect to the concept of virtualization? The concept of it, practically, I'll show you it now. Now, let me know, first of all, are we clear about the concept or not? All of you, please respond. Great. One or two questions over here. A virtual machine, is that just a virtual server? Exactly. A virtual machine, it is basically a virtual server sitting on top of a physical hardware, since it is virtualized with the help of a hypervisor. What does a file server do? A file server allows you to create file shares. In your corporate environment and all, you will be needing file shares for storing files and so on. So a file server will allow you to go ahead and create file shares. It will also store your files. A file server will be able to store all your files over there. Okay, so that is what we have with respect to a virtual machine. Let me show you this practically now. In fact, I told you about enabling this on a physical hardware, on a bare metal hardware without a operating system. But in fact, there are two types of hypervisor, type A and type B, or type 1 and type 2. What is the difference between these two types? The type A is something you install on top of a operating system. Okay, hypervisor can be installed on top of an operating system, as well as it can be installed directly on top of a physical hardware. Okay, so the one which we install, like for example, you already have an operating system, then along with the operating system, if you are enabling hypervisor or virtualization, then in that case, it is called as type 1 or type A, the first type. Now, if you have virtualization enabled or hypervisor installed on top of bare metal hardware, then it is called as type 2 or type B virtualization. So in my case, I do have a laptop over here, right, which contains an operating system called as Windows 11. So it contains a Windows 11 client operating system. So I told you I can enable this virtualization software on top of an operating systems as well. That is also a supported scenario, right? But that's not reliable, that's not efficient, not reliable, it's not efficient, right? Having it on top of an operating system is not much efficient. So in a corporate environment and all, you will be having it directly on a physical hardware itself, directly without an operating system. You will be setting up the hypervisor. But in our case, just to show you an example, how does all this look like, how you can create a VM, etc., to show you the sample of it, let me go ahead and enable virtualization over here on my machine. The condition is you should have Windows 8.1 or higher operating system with a enterprise license or a professional license, either enterprise or pro license. If you have any of this, then you can enable this Microsoft's own virtualization software, which we call as Hyper-V. Hyper-V can be enabled easily. So which means on this laptop, if I have Windows 8 or higher operating system with a Pro edition or Enterprise edition, I'll be able to enable the virtualization software over here. Or third-party VMware workstation or Oracle VirtualBox also can be installed. That is also okay, right? That is up to you. But anyway, for me, I'll just show you how to set up Hyper-V on the local machine. So now let's just validate the operating system. I'll go to settings. I'll go to, for example, what we call about. On about, you can see, for example, this hardware actually contains a Windows 11 Pro operating system. It contains a Windows 11 Pro operating system, which means I will be able to enable Hyper-V over here. So to enable Hyper-V on your local machine, just go to your start and then search for turn Windows features on or off. You just have to type turn Windows and then you will get the option turn Windows features on or off. So go to this option and from there you will be able to select a feature known as Hyper-V. You can see Hyper-V, there is a feature and it's already checked. In my case, it's already checked, it's already created, it's already enabled. So you just have to, in your case, you just have to enable it. Click OK, it will do a small install. You will need to restart the operating system. And once you restart it, you will get something called as Hyper-V. Hyper-V Manager. You will be having a Hyper-V Manager available for you, right? Now you can open up the Hyper-V Manager and you will be able to see it basically on your server. Currently, you can see I already have 1 or 2 VMs running over here. Let me just turn them off for now. Okay, so now you can see here on the Hyper-V Manager, now you will have the option to go ahead and create the VM according to your need. Okay, so you just have to go to start and then type Hyper-V Manager, right? Hyper-V Manager. I told you, first of all, you will need a restart. Once you have enabled it, you will need a restart. Once after you do the restart, you can come back to Hyper-V Manager. You will be able to see it. And when you go to Hyper-V Manager, this window will open. And from there, you will be able to create VMs for you now. Okay, fair enough. So now, is Hyper-V same as Windows Hypervisor platform? Yes, Hyper-V is actually coming from Windows only. Okay, so now here on the Hyper-V, I can right click on my server name. Under Hyper-V Manager, I can see the server name. I can right click. I can click on new virtual machine. I just want to create a new virtual machine. And then you can go through the VM creation process. So basically, I'm creating a virtual machine on top of my physical hardware on top of my laptop. So I'll click on next. First of all, let's just validate what are the resources that is available for my laptop. I'll go to Task Manager. And in Task Manager under performance, you can see currently I have 8 core CPU I have, and I do have some 16 GB RAM capacity available total, out of which 9.8 GB is currently available. Okay, 9.8, 9.9 GB currently is available for me. And disk capacity is also available. Somewhere about free capacity will be available for me. Let me just validate it. I have some 84 GB capacity available. Okay, so now we have enough capacity on the hardware. Let's go ahead and create a virtual machine. So go through the steps for creating a VM. I can just name it. I will, for example, say VM4 and then continue with the next. Generation 1, generation 2, you don't have to worry about it for now. Just continue with the next. And here you can define the RAM capacity that you want to give for the VM. For example, let's say I want to give 2 GB RAM capacity, right? So I'll give 2048 MB, which will give me 2 GB RAM capacity. Continue with the next. Network and all I'm not configuring. And here you can specify the hard disk capacity as well. So I'm creating a 20 GB hard disk for the operating system for the VM. And here is the option for you to go and install an operating system. So here is one option saying install an operating system later. I want the operating system to be installed right now, in which case I can say install an operating system from a bootable CD DVD ROM, and then I can say a image file. What is an image file? Image files are nothing but ISO files which you can download from internet. In fact, there is actually a place called as Microsoft Evaluation Center or Windows Evaluation Center. And for example, if you wanted Server 2019, you will be able to go to that website, Windows Server 2019 Microsoft Evaluation Center. So go to this Evaluation Center. You just have to fill up the details over here. I mean, you will have the option to download. You can see, for example, evaluation options. You can download Windows Server 2019 64-bit ISO. Okay, you will be able to download it. Where is the download option? Let me show you. Download the ISO. One option is available for you. So for example, if you wanted to download here for you to practice, you can click on download this ISO. They will ask you a couple of details. Just fill in all the details and you will be able to download the ISO image. When you download the ISO image, that will look something like this. If I go to the D drive, I have already downloaded it, and you can see this is something called as a server 2012 R2 ISO image, a Windows Server 2012 R2 ISO image I have kept over here. Okay, so in this way you will be able to get a image file, and that can be used for installing the operating system over here. So I'll just go to this image file option and I'll point to that image file which I have. Okay, I selected the Windows Server 2012 R2 image file. Continue with the next, and finally you can click on finish. What is the minimum RAM required? Minimum 2 GB. 2 GB and all you will need, only then the server will run properly. So 2 GB, 1 GB also it will run, but it will be too slow. Minimum 2 GB and all you can give for the RAM capacity. So now that I have created a VM4, okay, I have created a VM4. Look at this now. Here on the right hand side, I have the task manager, and I'll just keep this Hyper-V onto the left hand side so that you have a clarity with this. Okay, here we go. And on the right hand side, I have the task manager as well. Okay, look at this memory utilization. Currently, it is going with, for example, 6.2 GB. On the right hand side, on the left hand side, I'm going to start this VM. Okay, now watch this. VM4 is getting started, and look at the graph over here. See, 2 GB. This is the difference of 2 GB now, right? You can also see an increase in CPU utilization on top, right? CPU also got increased. Okay, so here now memory utilization got increased. So what happens? This VM is currently running on my laptop's hardware, utilizing the underlying CPU, RAM capacity, and hard disk, and so on. And that difference you can already experience over here. It has taken a 2 GB extra now, plus CPU is also going high now, a little bit higher. Okay, so let's come back to this VM now. I can click on connect. So when you click on connect, you can see this VM has already booted from the hard disk, and it is asking, okay, do you want to install the operating system? You can see Windows Server 2012 R2, right? And those people who know about the operating system installation and all that, they would know the process to get it installed. In fact, you don't have to worry about the operating system installation and all that. That's not required for us. But anyway, I will just have it installed. I'll click on install now, and you can see the setup is starting, and eventually it will complete the installation and you will be able to get inside the VM. Okay, I already have a virtual machine over here wherein I have done the installation. So let me just show you that. For example, I'll start this guy called as VM2. Let me start this as well. So for example, I'm starting a second VM. Look at the utilization, it further went up, right? It again went up now. So total RAM utilization currently is 10 GB. Remember previously it was 6 GB and 2 plus 2, 4 I have given. So total now 6 plus 4, 10 GB is being utilized from my underlying RAM capacity. If I start a third VM, that'll take another 2 GB because all of them have configured with 2 GB RAM capacity, and that will go to 12 GB total now. I can keep going till the maximum capacity that I reach. It does not mean that, okay, you have to utilize it to the fullest. You have to keep always a buffer. You have to keep it like somewhere about some 12, 14 GB and all you can utilize, and that would be much more ideal. So let's go inside this VM. I'll connect to it. And you can see now, this is asking me for the username and password. Let me just give the password that I have given for this. And do you see this now? I'm actually running a Windows Server operating system on my Windows 10, right? On top of my Windows 11, I'm actually running a Windows Server operating system now, right? So this is what the benefit of virtualization. You can virtualize a physical hardware and you can have multiple VMs with varying operating systems installed on top of it. So now, for example, one of my another VM, it can contain, let's say, for example, a Windows 10 operating system, or maybe it can contain a Windows Server 2022. It can contain a Linux operating system. So all this mix and match is also a possible scenario. So according to my requirement, whatever VMs I want, I'll be creating on top of my physical hardware. So this is what happens with respect to virtualization. Are we clear on the concept of virtualization, guys? Are we all clear on the concept of virtualization, practically as well as theoretically? All of you please confirm. One question, can we use this VM from different machine using remote desktop connection? Yes, you can. Okay, you can actually take RDP to this machine differently from different machines and all that. And that is exactly what you're doing. Whenever you access your VDI infrastructure, or whenever you access any machine via remotely, in fact, you're getting connected in the backend most likely onto a VM nowadays. Okay, and this is how it is configured in the backend. So now you got some idea as to what exactly the virtualization is all about. Just a quick second before we move on. There is a question, what is the difference between, repeat the type B virtualization? Okay, type A and type B difference is type 1 runs on bare metal hardware, or type A runs on bare metal hardware. Type 2 or type B runs on an operating system. What we have done right now is actually type B. Okay, that's it. Okay, so moving on. So now we understood the concept of virtualization, but let me ask you one quick question. Okay, let me ask you one quick question. If this underlying physical hardware fails, this physical hardware over here fails, will it cause any problems? I mean, will it bring all these VMs also down? Yes or no? Question is, if this underlying physical hardware, some failure it has, power failure or something, the power got disconnected, or maybe the underlying physical hardware having some other issues, in which case will these VMs survive? Will they keep running? Think of it logically. They will not run, right? Why? Because it is taking the resources from where? It's taking the resources from the underlying physical hardware, and that physical hardware is turned off, which means the VMs also will not run because they don't have the existence when the underlying physical hardware is itself is down, right? So this is a problem. You cannot have this kind of environment in a production, so that would cause you troubles, right? Because there is a single point of failure now. So that is where you have to go with the concept of high availability. So it is also possible for you to set up something called as high availability with virtualization. And that is the foundation for something which we call as cloud computing. Okay, so listen carefully. But before that, one quick question: how to see the IP or VM address to access? Currently on this VM, which I have just shown you right now, I have not configured any IP address. Okay, there is no IP address which I have configured because I did not configure networking for this guy. So I have to have networking configured, then I'll be able to see the IP address. Currently, you can see, if you look at this network here, it clearly says it's not connected because I have not configured network. If it is configured for network, I can give IP config and I'll be able to see the IP address. Currently, there is no IP address and I cannot connect to it via IP address. Okay, for now. If I configure networking, yes, I'll be able to. Moving on. So now you can see here, there is a single point of failure over here. If this particular hardware fails, all your VMs will go down, and that is a problem, something which we have to address. So that is where whenever you deploy a environment, you will not be deploying it on just a single physical hardware, but rather you will buy a group of physical hardwares together and you will pool them into something called as a cluster. You will pool them into something called as a cluster now. So what happens in that case is, now you have more than one physical hardware available. Okay, you have more than one physical hardware available, like for example, another physical hardware, maybe a third one as well. Okay, so some 2, 3, or even more number of more than 2, minimum 2 or more. Okay, number of physical hardware you will buy, powerful physical servers, and you will also introduce something called as a SAN storage. That is also required for high availability. You have to have something called as a SAN storage. Okay, a SAN storage device. A SAN storage means, SAN means storage area networking. Full form of SAN is storage area networking. So that allows you to have shared storage, something called as a shared storage for all the servers. So which means all the servers will be able to access this particular SAN and write or read data from the SAN. They will be able to store their data and all on the SAN. This will be used as a central storage repository for all the servers. Anyway, now when you set up in this way, what happens here is, combining all this, you will have something called as a cluster created. You will have a cluster created out of all this. Okay, a cluster will be created from this now. Let me just mention that over here, you have now a cluster. Okay, and when you create a cluster, of course, as I told you, you need 1 or 2 separate servers. From where? Separate servers. These are not virtualized, but rather separate servers from where you will be managing the cluster. You will be managing the cluster. So for cluster management, you will have 2 different, or 1 or maybe 2 different servers will be there who will be managing this entire infrastructure now. Okay, so all these guys will be interconnected on network, and you will be able to access these servers and all from this cluster management software over here. You will have a cluster management software installed on both of the servers, through which you will be able to control this whole infrastructure. Okay, so when you do that, it will also give you something called as a portal. A portal means either a portal or an application. Either a portal or an application you will be having on the servers, through which you will be able to control all this physical, or for all this virtualized environment. A portal means what? A portal means a web page that you can access, from where you will have now the options to create a VM, delete a VM, add virtual disk, and all these options related to this virtualized infrastructure, you will be able to do it from the portal now. Okay, in such a way, when you set up the cluster, you will have an option to manage this entire infrastructure via this portal or via the application. Okay, so now this is what we call as a private cloud environment. Why did I call it as a private cloud now? Now you can see what I have created here is a highly virtualized infrastructure. When I say highly virtualized, that means I do have a couple of servers now. All of them are virtualized and they are being centrally managed on a cluster. Okay, so when you have a centrally managed cluster with all the servers being virtualized, then in that case, we call them as a highly virtualized environment. So in such a highly virtualized environment, I will be able to manage them. As I told you, I will be able to manage this infrastructure from a centralized location called as a portal or maybe an application. Such a scenario is what we call as a private cloud environment. Why the term private came in over here? The private actually refers to under the ownership of one company or one individual. So typically, this would be set up by one company. In that case, we call it as a private cloud environment. Dedicated for that company, they have created a very highly virtualized environment with multiple servers, and they are being centrally managed and all. They have created an environment for their use cases only. So once you have such an environment created, now through the portal, just like how you have seen on the Hyper-V manager, through the portal, you will be able to create VMs, move VMs from one physical hardware to another. For example, this VM over here, if I see any problem with this physical hardware, I can have it moved onto another physical hardware now. Maybe all those 3 VMs I can move, right? And I can create multiple VMs, etc. All these possibilities now will come when I have more than one physical hardware, right? So now even if there is a problem with another physical hardware, not a problem. Why? Because you can easily move your virtual machine from one underlying physical hardware onto another physical hardware. Okay, and the VM will be running on the second hardware now. So in this way and all, you will be able to achieve high availability when you have a highly virtualized environment. This is the base of cloud computing. So whenever we talk about cloud computing, in fact, in the background, in the back end, this is what you have. This kind of infrastructure you will be having, and all the virtual machines and resources and all that you're creating is actually going on top of these infrastructure.
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
For now, let me show you one example of a portal when you go and set up a centrally managed portal and all that cluster. When we set up, how the portal will look like, let me show you. For example, so if I go back to Azure, sorry, if I go back to Google, let me look for System Center Virtual Machine Manager. This is actually one of the cluster management software. And if you go to images, you will be able to see the portal from there. Okay, this is actually one of the portal that you are seeing over here. You can see here our Hyper-V servers, our VMs, sorry, our physical servers, which we have virtualized, and then all the VMs running on both of them, you are able to see. You have the options to create VM and all that. You will be having the respective options and all for that. Okay, you can see this all are your VMs and all that is running on a cluster management software, right? You can see here, this is another one, another image. Okay, this is a cluster management software, not a portal. So in this software, now you can see there is an option to create virtual machine. You have the Hyper-V servers, the hosted, which we refer to as a host, etc. that is available, and all these things can be managed from here now. Okay, now can we change the specs for RAM storage of the VM? Of course, yes. So anytime, for example, you wanted to increase the RAM capacity on any one of the VM, or CPU on the VM, or hard disk capacity on the VM, on the fly, you will be able to do that. You will be able to go and increase the RAM capacity and all that as per your requirement. So that is a benefit, additional benefit that you're getting, because now you will be able to scale your VM to higher capacity as per your requirement. Okay, so that is what we have with respect to a virtual machine. Does it all make sense now, guys? Does it all make sense, or it all going above your head? I mean, I believe now you would have got some basics as to, okay, what exactly is happening in the backend. Now, at least when you go on to cloud computing, you will be able to relate, okay, in the backend, this is what you have. Okay, you will be able to relate and understand things much more easily now when somebody is talking about cloud computing and all that. Data stored using VM or some other ways. See, I told you for the virtual machines, you will be having something called as virtual hard disk. The data storage for these VMs will be on a virtual hard disk file, and this virtual hard disk files will be sitting on the SAN, on the SAN storage. Okay, so that's where I introduced something called as a SAN as well over here. So data storage typically will go to the SAN storage from all these VMs. All of you, please confirm, are we good so far? Now, fair enough. So let me just reiterate on the last part, what we discussed. Listen carefully, all of you now. So what I said initially, we had a single bare metal hardware, and then we virtualized that single bare metal hardware. We created VMs on top of them. Then I asked you a question. Do we have a problem over here? For example, this physical hardware is failing. If it fails, will the VMs be affected? And we clearly know that is the case. If this hardware fails, these VMs will be affected, because all the RAM, CPU, etc. is taken from this underlying physical hardware, and also these machines are living on top of this physical hardware. So which means if this physical hardware itself is dead, then your VMs are also dead, right? And that is what we call as a single point of failure. A single point of failure. Correct? A single point of failure means if this underlying physical hardware fails, all our VMs will fail. Does all of you agree on to this part? Okay. A single hardware fails, all your VMs will get failed. Perfect. Let's move on. So what is the solution? How can I address that problem? So that is where I told you, whenever we create a virtualized environment, we don't create it with a single physical hardware. If you're creating it with a single physical hardware, then in that case, it is called as standalone virtualization. A single physical hardware, if you're virtualizing, then in that case, it is called as a standalone virtualization. On my laptop, I created VMs. Is it a standalone virtualization? Yes or no? On my laptop, if I create VMs, is it a standalone virtualization? Of course, yes, it is actually a standalone virtualization. If I turn off this laptop, these VMs will not run anymore. Okay, that part is clear. So that is where I told you, you will not do standalone virtualization in a corporate environment, but rather you will have something called as, or you will introduce more than one physical hardware. You will introduce more than one physical hardware, which means a second and a third hardware will be introduced, or even more than that. Minimum two. Minimum two. More, you can have any number as per your requirement. So now I have couple of physical servers together who are, all of them are powerful enough. Okay. So now the next step is, when I introduce multiple servers, to combine them and to work them together and to guarantee this feature called as high availability. To achieve this feature called as high availability, what I have to do now is I have to create a cluster out of them. I have to configure a cluster out of these three physical servers. If I create a cluster, only then I will be able to go and achieve this high availability. So provided whenever you have more than one physical hardware to be virtualized, you have to create a cluster out of them. One of the requirement for the cluster is the cluster needs to be managed from outside of these physical servers which are getting virtualized. What is the purpose of these physical servers? These physical servers we will virtualize and we will have VMs created on top of them. So which means to manage them, now you need a additional server. You need a separate server wherein you will go ahead and set up this cluster software. For creating this cluster, you actually require a software. And examples of that software is actually something called as System Center or OpenStack or VMware vCenter or VMware vSphere. VMware vSphere. These are the examples of cluster softwares. So now what you will do, any of the software according to your requirement, you will be deploying it on a separate machine now. And using that System Center software or OpenStack software or VMware vSphere, which you configured on these servers, you will combine these servers into a cluster now. Okay, you will combine these servers into a cluster now. So what happened now? I got a cluster created, and within that cluster now I have three physical servers. Now these three physical servers, we will refer to them as host. Host in the sense they are hosting virtual machines. So now I got a physical cluster with three different hosts, right? Now, along with this particular host, I will also introduce something called as a SAN storage. A SAN storage. What is a SAN storage? A SAN means storage area networking. The full form of SAN is storage area networking, which is connected onto your network. So all of these devices, this is connected to my network. This is connected to my network. This is also connected to my network. These servers are also connected to the same network, including the SAN. All of them are connected to the same network. Now, the point of SAN here is this guy will contain a lot of hard disk. He will contain a lot of hard disk. He has a lot of storage capacity with him. For example, we have Dell EMC and all that. Dell EMC, SAN and all, we have it, right? So these kind of devices, once you introduce them onto the network, the purpose of them is all of these physical servers that you have, the host that you have, now they will be connecting onto these SAN. These guys will be connecting onto the SAN. Now you will ask why they are connecting onto the SAN. The point here is, remember, we are creating VM. We will be creating VMs on these physical hardwares on the host. For this virtual machine, they require storage. They require storage, right? For storage, virtual machines uses a terminology called as VHD, a virtual hard disk. Virtual machine does not have physical hard disk. What they will have is something called as a virtual hard disk. This virtual hard disk needs to be stored somewhere. First of all, let's consider one scenario. You are storing this virtual hard disk on the underlying physical server itself. Okay, you are storing your 200 GB virtual hard disk on this underlying physical server itself. When this particular server goes down, will that VHD also go down? Yes or no? When the physical server goes down, will that VHD also go down if it is stored on the same physical host? Of course, yes, it will go down. It will go down. So that would be a problem. So that is why, to make sure we don't have the disk of the VM going down, what we will do, we will instead store the VM's disk over here on the SAN, which means the virtual machine is running over here, but the storage is actually coming from the SAN via the network, right? So this is why we introduced a SAN storage over here. Repeating one more time, all the physical servers will be connected onto the SAN, and all the VMs running on top of them will be connected to the SAN storage, and the virtual machine's hard disk, the VHD file, will not be stored on the underlying host, but rather that will be stored on the underlying SAN, which is connected to the network. Then you might ask, okay, what if the SAN goes down then? Right? Now SAN is a single point of failure. What if he goes down? No problem. In fact, every SAN will actually contain two controllers and multiple disks in RAID configuration, in RAID RAID configuration. So if anything goes off on this hardware, that will be either the controller or the hard disk. If the controller goes off, you have another controller. If any one of the hard disk goes off, you simply need to pull out that disk, add another disk, and the RAID will do the rest of the job. RAID will reconfigure that particular disk without any data loss. I don't want to talk more about RAID because it'll take a lot of time, so we don't have to worry about it. I'm just giving you the high availability scenario on a SAN device. The storage controllers will be there, multiple storage controllers, and then you will also have disks configured in RAID, which will give you protection from failure. Additionally, also it is possible for you to have a secondary SAN as well. If you are much worried about the data storage, then you can have a secondary SAN as well, okay, which will give high availability for the SAN storage now. So this is why we introduced a SAN onto the cluster. Giving the final overview. So now you have multiple physical servers, which we refer to as host. You're creating a cluster out of it by using a cluster management software like System Center. You will have a SAN introduced onto the cluster for the VM's disk storage. All the VMs will be storing their disk on the underlying SAN. For high availability on the SAN, you will have RAID configuration plus multiple storage controllers plus, if required, multiple SANs also. Does that make sense now? Does that make sense now? So far, are we clear? Okay. And final thing, then I told you, now System Center, you will have an application. For example, System Center is actually an application now that we have, right? And now from this application, you are managing all this. Where this application is running, it is running on this VM. Now, also, apart from the System Center application, this management can be done through a portal interface. A portal interface. A portal means when you set up the System Center, they will set up a web-based application also over here. A web-based application also will be available for you over here. This is an installed application. You can also have a web-based application. This web-based application is what we call as a portal, right? Portal, typically it will be having an IP address. So this portal will be running on this IP address itself. For example, if this machine has an IP, on that IP, the portal will be available. So you will type that particular IP and you will see a portal. You will have an exact same interface how you will see on the System Center application. So through that portal also you can manage this environment, or via the system center application also you can manage the environment. That is what you will be getting. So this is what I meant by saying a portal. Now that screenshot of that particular portal is what you can see over here, or that application is what you can see over here, through which you will be managing your cluster. Now you can see, for example, if I go here, this actually contains a cluster, and in that cluster you have there is only one single hypervisor host over here, and there are a couple of VMs running. Another example, if I go to the top, you can see here we have minimum 2 servers available, and there is at least 1 virtual machine running on them. Right? So complete overview of the infrastructure you can get from this portal or from the system center application. I hope now that gives you a clarity. Does that make sense now? Okay, so now you understood a highly virtualized infrastructure which is combined from all these things, whatever we explained so far. And this is exactly what we call as a private cloud, right? A highly virtualized infrastructure which has a storage, a SAN introduced onto it, and then there is a system center management software and all this. So completely everything put together is what we call as a private cloud environment, a privately held cloud computing environment, wherein you have a management portal through which you will be able to create VMs as per your requirement. Okay, so this is what we call as a private cloud. One quick question: can you define high availability? High availability means the ability to sustain at least one VM in the event of a failure. That is what we call as high availability. So now when you do application deployment for achieving high availability, what you can configure over here, you can deploy your applications onto minimum 2 VMs. One VM you keep over here, another virtual machine you keep over here, and same application you will deploy onto both of them. So if this underlying hardware goes off, your application will survive from this VM because it is running on a different hardware now. Also, you will be able to, in some cases, you will be able to move this VM from here to a different hardware which is running fine. That is also will be supported. So all this are part of your high availability scenarios. Okay, that's it. So now so far we just explained the basic things related to, okay, what exactly we have with respect to a private cloud now. Okay, we came up to the private cloud part. So now we are moving on to the final thing, that is actually what is your public cloud environment, or what is Azure, AWS, GCP, and all this. So now it is easy to understand. So you understood so far what is there in the backend. And now let's go ahead and talk about how come this cloud computing or cloud came into the picture now, or the public cloud, what we refer to as. Just let me just clear out all this mess. So now that we are on the private cloud environment, so what happened now from here is, now we have MNCs, multinational companies. So these companies, like for example, Amazon was the first one to do it, then followed Azure or Microsoft. So these companies, Amazon or Microsoft kind of companies, they do have data centers across the world already. Microsoft and all, before even cloud computing, they were operating from the different parts of the world. So they did have data centers already available across the world, including AWS or Amazon. So what did they do is they thought like, okay, we can create a infrastructure like this. Just now what we explained, in that way we can create certain infrastructure on a large scale in the sense with more number of servers, with more number of storage servers and all this large infrastructure we can create it. And then this portal, which I explained to you over here, through which you will be able to manage this particular environment, you can create, or we will go ahead and create a portal which is available on the internet, which can be accessed via internet. Okay, such a portal will create, and then we will allow users from the world, from across the world, from across companies or individual users, we will allow them to go ahead and utilize our environment and create machines, virtual machines or services on our environment. Okay, so basically these MNCs, what they are doing, they opened up their private cloud for the public. They created a portal which is accessible across the world. Through this portal, now users will be able to go and create resources or virtual machines on their environment. And this is what we call as a public cloud. Okay, this is what we call as a public cloud. Do we have a clarity now as to what happened with respect to public cloud? I'll give you a definition for this later, but right now, did you understand what exactly became known as a public cloud environment? Yes or no? Okay, so now let's talk about a definition for cloud computing. Okay, so a cloud computing means delivery of computing services over the internet. In simple terms, the simplest terms that you can make available or that you have for cloud computing is nothing but delivery of computing services over the internet. Simple as that. Over the internet, from where it is coming? It is coming from the CSP. CSP means Cloud Service Providers Infrastructure. CSPs are, for example, Azure is one CSP, Cloud Service Provider. AWS is another CSP. GCP is another CSP. So from these cloud service provider, they are making their infrastructure available to you. They have created their infrastructure, very powerful, huge data centers that they have created. And these data center infrastructure, they are making it available for you so that now you can go and create resources on their infrastructure. Anybody across the world will be able to use them, provided they have something called as an account in the first place. They have to create an account with Azure, or they have to create an account with AWS, or they have to create an account with GCP. So once you have signed up and you have the account created, next thing that you will need a billing agreement as well. A billing agreement in the sense, for example, when you have Amazon Prime or when you have Netflix, you have a billing agreement with them, which we call as a subscription. You have a subscription with them. You subscribe to their services on agreement that you will be paying them for the services that you will be using, right? So that is what we call as a subscription. So you will need an account plus a subscription, in which case you will be able to use cloud services from any of this CSPs, cloud service providers, CSPs like AWS, GCP, Oracle, IBM, and so on and so forth. Okay. Your question, GCP is Google Cloud Platform. That's right. Cloud Platform or CSP, Cloud Services Provider, which is from Google. That is what we have with respect to GCP. Okay. So this is what happens with respect to a cloud computing environment. Now, basics of the cloud computing has been covered. Now, let me ask you a couple of questions over here. Initially, you remember, we talked about three problems. One was the cost, one was the maintenance, one was the scalability. Okay. My question is, will these problems get addressed when you move on to cloud computing environment? Yes or no? Okay, so the answer for that is, first of all, yes, they will get addressed when you move on to cloud computing environment. Let's talk about it. For example, let's consider the first problem that we had with respect to cost. Okay, will the cost problem be addressed? Let me ask you, I told you about the cost category. There are two categories of cost that is applicable for you when you set up an infrastructure. One is called as CapEx and another one is called as OpEx, capital expenditure and operational expenditure. When you go out and create VMs or resources in cloud, do you have any capital expenditure for that? Do you have to make any initial investment to use Azure cloud or GCP cloud services? There is no capital expenditure. So which means you are saving on that millions of dollars that you would have been spent on setting up the infrastructure initially, which we refer to as capital expenditure or CapEx. The CapEx is not applicable in the case of cloud computing environment. So that is the first benefit that you're getting. So any company, even if it is a startup, if he wanted to have his IT infrastructure, he can set it up on the cloud and he will save on the CapEx part. So the life becomes easy for him. What you have here is in the cloud computing environment is something which we call as OpEx, operational expenditure. As you utilize these services on a monthly basis, you will be getting a bill which you will need to clear. Okay, and that is added on to our operational expenditure. As the operations goes forward, whatever expenses recurring monthly is what we call as operational expenditure. And typically when a company is functional, they will have cash inflow. So these OPEX will be addressed in this inflow, cash inflow, and you will be able to move on without any problems. Of course, OPEX, I told you, it's your monthly bills that is coming every month. You have to pay for it. You have to get it cleared. So in this way, you will keep on moving. But initial very large amount investment that can be completely avoided. And also on cloud computing, you pay only for the services that you use. You don't pay for anything that you did not use. You pay only for that you use. For example, you have an Azure account. You have created the Azure account, and then you have the subscription as well. But if you are not creating any services over there, will you have any charge for it? There is no charge because you are not utilizing anything. Only if you utilize, then there would be a charge applicable for you. Okay, so that's what happens with respect to cloud computing environment. We refer to this payment term as pay as you go. As you go forward, you pay for it as per the services that you're using, and that is what we call as pay-G or pay as you go. One question here: who is the market leader in CSP? As of today, in cloud service provider, the market leader is Azure. Okay, Azure is the leader. It was AWS so far, but in this quarter, Azure has overtaken AWS. Moving on. And then, so I gave you the definition for cloud computing. We got a clarity as exactly what happened with respect to cloud computing. What do we have in the backend in all this? Now you have certain idea. So now that being said, let's go visit one of the CSP's portal, Azure portal, which we refer to as. So for that, remember the URL that we have with respect to Azure portal is something called as portal.azure.com. So you have this portal.azure.com that is available for you, through which you will be able to access Azure services. When you go to portal.azure.com, remember, you will have to log in with your account. So once it's logged in, you will be able to see the portal like this. I told you have to have a subscription. So if you have a subscription, then you will be able to go and create resources in the Azure portal. Okay, so this is the Azure portal. Similarly, you have AWS portal, we have GCP portal, any other cloud computing platform, they also will have their respective portals available for you, through which you will be able to create the resources now. Okay, so now that being said, let's try to create some sample resource over here. In fact, we will create a VM itself on this Azure cloud computing portal. In Azure's environment, we'll go and create one virtual machines. Conditions I told you, I need a account, I need a subscription. If that too is in place, I will be able to go and create a virtual machine over here. Those two I do have it. In your case and all, if you want to practice Azure, you will have to go and set up a trial subscription. You will have to set up a trial subscription. You can set up trial subscription easily. You just have to, for example, go to azure.com, and when you go to azure.com, you can see there is an option called as try Azure for free. You just need to click on this try Azure for free, log in with your Microsoft account, and they will validate if you are eligible for a free account or not. So once you go through the validation steps, if you are eligible, you will need to provide your name, details, name, address, phone numbers, PAN card details, all this. And you will also need to provide a payment information. When you add payment information, they will charge you 2 rupees or $2 from your account. That is only for validating the payment can be done successfully. Does not mean that for a free trial, they will charge you. They won't charge you for a free trial. They're just making sure it's actually a genuine request coming from a genuine user. And once it is validated, what they will do, they will go and have the account created for you with a free trial subscription. Then using that free trial subscription, now you will be able to create resources. You will get somewhere about $200 credit or 13 or 14,500 rupees credit in INR. You will be getting, you can utilize it for a month's period and you will be able to practice with it. Okay, do that only if it is necessary, because later on, if you wanted to practice, once you utilize your trial, you will not be able to utilize it again. Okay, so those of you who want to practice, you can sign up for Azure for free and have it practiced. Okay, so that's it. For free only for first 30 days, or we can choose any 30 days. Only for the first 30 days. You cannot choose any 30 days as per your requirement. From the day you activate it for another 30 days, it will be available for you, the first 30 days. If it's not deviation from the topic, can we have some info on the security as an KPI in cloud versus on premises? Every company's initially, in fact, this is a slight deviation from the topic, but anyway, I'll just give you a quick overview of it. Every company do have certain security concerns, as to say, when we move on to cloud computing environment and all that, will it be a secure practice? I mean, we are keeping our data on a different computer now, not in our ownership, we are putting it onto different data center. So will there be any problems, right? So one of the things that there is, Microsoft is actually having a lot of policies in place, security measurements in place, security mechanisms in place, with which you can make sure, even if you keep the data on their data center, that is encrypted and that is secured and that is not accessible by third party. In such way, you will have the options to keep the data. Plus, Microsoft being an internationally recognized company, they will have to agree to certain security policies which are known and practiced globally. Like, for example, you have your PCI DSS compliance, you have your, like, for example, GDPR norms compliance. So these kind of policies and all will be there in place, to which Microsoft strictly adhere to. Even though GDPR, General Data Protection Regulation, some of you might have heard about it, GDPR, even though that is not applicable in India, that is mostly applicable in Europe. And then Microsoft is,
Just a quick info, guys. If you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
going ahead with this GDPR norms on our India location as well. So these kind of policies, when you have in place, you can be assured that, okay, there will not be any security challenges with respect to moving on to the cloud. Okay. Now, apart from that, now there are many security options which we don't have to focus for now with respect to securing the infrastructure that we have, and make sure we don't have any problems with respect to the data and all this. But that's not the point of discussion that we have for today. Okay, fair enough. Okay, so these free services for a year is not available with trial. Trial period is available only for 30 days. Trial period is available only for 30 days. Once after 30 days, that 14,500 rupees or $200 worth of credit that you have got will be elapsed. If you have not utilized, that will be elapsed, or if you have utilized, it will be done, and that will not be available for you anymore. For now, moving on to some basic service creation in the Azure portal. So since we know what is VM, let's go to virtual machine only. So in Azure portal, you can go to the virtual machine service, or directly you can search. If you are not able to find this virtual machine service anywhere over here in the home page, you can go to the search bar on top and then just start typing virtual machine. So when you type virtual, there itself you will be able to see the virtual machine service. You can click on it. Once you click on the virtual machine service, click on create for creating a basic Azure virtual machine. Just say that, okay, I want to create Azure virtual machine, and then click on create. So now on this page, this is where you have to go and select the required settings for your virtual machine. For example, I told you, whenever you want to create some resources in Azure, the first thing is you need to have an account. Account we have already. Then you need to have a subscription. Okay. And you have a subscription only, then you will be able to create a resource. So in fact, you have the option to select that subscription. So when you create this virtual machine, you have to specify, okay, this needs to be created onto a subscription. In my case, I have multiple subscriptions, so I'll go ahead and choose any one of them. In your case, if you are having only free trial, there is nothing to choose. Automatically that free trial will be selected and you will be good. Then you have to create something called as a resource group. A resource group is actually a logical grouping of your resources. For example, based on a project and all, you can group your resources together into different resource group. That's all the idea that you have here. You can compare it, like, for example, your dress items that you have, for example, a couple of jeans, you have certain t-shirts, you have some shirts, etc. Right? So you will keep all this jeans in one single container. then all the t-shirts in another container, and then maybe all the shirts in another container. So you have logically separated them. So once you have logically separated them to 3 different containers now, it's easy for you to go out and pick up a jeans whenever you want to pick it up, right? So the same way, when you create resources in Azure, instead of grouping everything together, logically, according to the logic that you have, it might be project based, it might be department based. On all this logic, you will be creating certain resource group. For example, if my company is working on 2 different projects, I can create one resource group for the first project, another resource group for the second project. All the resources I'm creating in Azure related to the first project, I can keep it on the first resource group. All the resources related to the second project that I'm creating in Azure, I can keep it on the second resource group. So this logical grouping of resources is what we call as a resource group. So I'll go ahead and create a logical grouping newly. I'll go ahead and say, for example, demo RG is the resource group name, demo resource group. And then I'll specify a name for the virtual machine. So I'll just call it as VM1. Now remember, there is something called as region. What is region? So Azure, across the world, they operate from specific locations. Specific location in the sense, across the world, they have selected certain areas wherein they have set up their data center. For example, let me quickly show you one diagram over here, which will show you which are the Azure regions that is available for you. If you go here, you can see there is actually one diagram, Azure regions map, and you can see it over here. Okay, so here you can see across the world where and all Azure is available. All these blue circles that you see from these regions and all, Azure is currently operating and it is available. Okay, in India location specifically, if you see, you can see that it is available from 3 different regions in India called as West India, Central India, and South India. In fact, South India is Chennai. They have data center in Chennai. In Central India, Pune, they have data center. In West India, Mumbai, they have data centers, right? So in all these locations across the world, in different locations, total 62 plus regions, Microsoft Azure has presence as of today. You can see in United States as well as in Europe and all, we have so many data centers available. We have in coming in Africa as well as North and South Americas and all that. In all these locations, you are able to see, you can go and see the regions that is available for you. So while creating the VM, what you're doing here, you're choosing the region on which region you want this VM to be deployed. So in my case, I would say I want it to be deployed in Central India. Okay, in Central India. So now when you go ahead and select Central India, which means when I create this VM, in the back end, it will be created in Pune in Microsoft's data center. Then here is the operating system image. Remember, while we set up the VM locally, I showed you creating the VM or installing the operating system from a image, ISO image. Here in this case, you will use images available from Azure's marketplace. Azure marketplace contains a lot of images falling into your Windows operating system, Linux operating system, and many other operating systems are supported. You can go ahead and choose whatever you want. For example, I'm selecting a Windows Server 2022 data center Azure edition. Okay, and here is something called as VM size. So remember, I selected 2 GB RAM capacity and 1 core CPU or 2 core CPU for my virtual machine. So now in Azure, you don't specify like, okay, this is the amount of RAM and this is the amount of CPU, but rather you go and pick up something called as virtual machine size. In Azure, we have virtual machine size. So you go and choose from available VM sizes. There are so many VM size that is available, which will give you varying capacity. For example, current selection is on standard B2MS VM size, which will give me 2 virtual CPU and 5 GB memory capacity. And that would cost me approximately 5,000 rupees per month. Approximately 5,000 rupees per month it will be costing if I continuously run it. Only if I continuously run for 1 month, then that might cost me 5,000 rupees approximately for a month. A standard B2MS VM, which will give me 2 virtual CPUs and 8 GB memory capacity in the backend. So I'll select this B2MS size. And now for the VM, once it is getting created, I will need to log into it. I'll need to connect to it. So you have to have a username and password. So I'll give the username and password over here itself. Just let me give the username, sorry, password. Okay, so I'll give the password, and then for example, I'll go ahead and select here. Okay, so I gave the password, username and password, that got confirmed. And below there is something called as inbound port roles. One of the speciality of Azure VM, whenever you create a VM in Azure, by default, all the connectivity onto that VM will be blocked. In the sense, you will not be able to connect to that VM via remote desktop. This is a VM. Once we create this VM, this will be a VM running in a remote infrastructure. It is not running in our premises, right? When I created a VM over here on my laptop, it was running on my laptop. When I create a VM in Azure, it is running in Azure's backend, right? So that's a remote VM. So onto a remote VM, you would need to connect via a remote desktop. If it is a Windows VM, you will need to connect to it via a remote desktop. So now, by default, for this Azure VM, this remote desktop connectivity will be blocked. Remote desktop connectivity or RDP will be blocked. So I want to allow RDP, and that is why I'll go and choose select inbound ports, and then I say, for example, RDP needs to be allowed, and RDP is a protocol which is running on port number 3389. So RDP 3389 port number we need to allow over here, so that I'll be able to connect to this machine. If I don't add this, I'll not be able to connect to this machine. This much details you can give, and you can say finally review plus create. Just a second, there is a validation error. Let's go to networking and then give again review plus create, and then it should be okay. You can see now, if you run this VM for 1 hour, it will cost you only 7 rupees. Okay, 1 hour, it will cost you 7 rupees. That's it. So validation passed, rest everything is okay. Anywhere if you see validation error, just go to that particular tab and then click on review plus create again, and it will go through without any problem. There are many other options that you have to configure with the VM, but for the sake of doing it as a easy method, we are not getting into the advanced details and all with respect to VM. And in fact, that is not required for us as well. So I'll click on create for the VM now. Quick question, we already created VM. We created VM earlier on my local laptop. Right now, where am I creating the VM, guys? Right now, this VM it just got created, where it is getting deployed. So right now, we are creating this VM in a cloud computing environment that is in Azure. Remember, this VM is running in Central India region, which means as part of Azure Cloud, Microsoft has set up a data center in Central India, that is Pune. So in that data center, this particular VM is currently running. Okay, so let's go back to the virtual machine, and you will be able to see this VM running. So go to VM1. There is a public IP address available for you. Copy this public IP address, and you will be able to take RDP onto it. So to take RDP, you can just go to run on your local machine, provided you have a Windows machine, and there you can type MSTSC. Okay, Microsoft Terminal Services, short form for it, MSTSC. So type MSTSC, that will open up the remote desktop connection. If you are not remembering this MSTSC, just go to start and then type remote desktop. Just type remote desktop and you will get it. So go to that remote desktop tab and give the public IP address over there and click on connect. That will ask for the username and password. Give the username and password, for example, Shadil, and the password which I have configured earlier. Click on OK. Accept the connection request, and then you will be logged inside the VM. Okay, so basically the server image that we selected was a non-GUI one. Non-GUI means graphical user interface is not there. And that is why you are getting this option, welcome to Windows Server Data Center Azure Edition. Okay, so this actually, if you selected the proper image with GUI, in which case you will be able to see a graphical user interface without any problems over here. Okay, that's it. One question, IP address comes automatically in remote desktop connection? No. What did I do? I copied the public IP address from VM. I went back to the virtual machine in Azure. I selected copy from here. Now it became copied. And then I went to the remote desktop connection, and then I gave the IP address. I went to MSTSC, and then I gave the public IP address over here, and then I clicked on connect. That is how I got it. Okay. IP ID, is it your local machine? No. This IP address belongs to this VM which we have created in Azure. Okay, this is the VM's public IP, not my local machine's IP. It's coming from our Pune VM. In Pune, this VM has a public IP address assigned, and that is what 22.1.198.110. You created MORG and VM1. That's right. I created MORG and VM1. We don't need to start this. When you create the VM, automatically it will be started. Automatically the VM will be started. You don't have to separately start it. Okay. Which one will have the IP address? The VM will have the IP address. Resource group doesn't carry any IP address. Resource group is only for logically grouping the resources. It does not require any IP. IP address is only for the VMs. Okay, so any other questions on this, guys? Whatever we have seen up to creating a basic VM in Azure. And maybe if you want to, I can show you one more thing over here. Just a second. This I can close. Computer name is okay. Remote management, update setting, install updates, remote desktop enabled. Network setting, telemetry, the log of restart, shutdown, server, exit to command line, PowerShell. So I'll just go to 15. And that will take me to the PowerShell. So this is basically a PowerShell. Okay. So from PowerShell, I'm just modifying this VM. Okay, means we can save our data in Pune region. That's true. You are basically, if you save anything on this server, that is basically getting stored on Pune VM itself. I'm getting an error warning VM1 virtual machine status is not ready. You can simply avoid that warning and then try to connect to it and see if it is connecting or not. If it is not connecting, only then you have to worry. That warning will go away slowly. So now here on my local machine, somebody was asking if we can make some changes. Let's do some small changes over here and see the result of it. Okay. Remember, in Windows Server, by default, this is actually Windows Server. So by default, if you want to host any website, we have a default web server available in Windows. And that web server, anybody knows the name of that web server available in Windows Server? Anybody knows the web server name available with Windows Server? What is that web server called? IIS, Internet Information Services. Okay, similar to Apache, in Windows we have IIS, Internet Information Services. So let me go ahead and install this Internet Information Services over here on this machine. How do I do that? I'll say install hyphen Windows feature hyphen name web hyphen server and then hyphen restart if required. So this will go ahead and install the web server on my local machine. Okay, sorry, on my server on my VM which is running in Azure. Install hyphen Windows feature hyphen name web dash server and do a restart if required. Let me run this, start and see what happens. So you can see here now web server has been installed and we can validate it. How can we validate it? Just come out of the server, minimize it. And remember, we have a public IP address with the VM, right? So with this public IP address, you will be able to validate if the web server has been installed or not. But there is one condition. Remember, I told you by default, all the connections to the VM will be blocked and we've allowed only RDP connectivity. So now if you want to validate the web server has been installed, web server will work on a protocol known as HTTP. HTTP is the protocol that we use for web server. So you have to allow this HTTP protocol or port number 80 so that you can validate the connection to the VM. So you go to the networking tab to allow the connectivity via HTTP and you can see there already RDP 3389, which we allowed earlier. You can click on add inbound port rule option. And from here, you can leave all this part as it is, no problem. You come down to service and then you select HTTP, scroll down further and action you set it to allow, give it a name, give whatever name that you want and then click on add. That much only what you have to do, which will allow the connectivity via port number 80 now. Okay, which will allow the connectivity via port number 80 now. So once after this is saved, now if you try with the public IP address of the VM, you should be able to see the default page of IIS without any problem. So what you have to do is just give http:// and the IP address. Okay, so you can see you are getting the default IIS page. There is nothing risky with this. HTTPS Yes, ideally with any actual website and all, you have to use HTTPS. That is true. But this is only a web server wherein we have for testing just installed a web server. There is nothing risky over there. I have not kept any malwares or something over there. So there is no worry like, okay, you have to go with HTTPS only. Okay. For that sake of testing, you can do it with HTTP and that is absolutely okay. So now what have you done? You have created a globally available website now. Anywhere in the world, if a user is trying to access this, they will be able to see the website. They will be able to see the IIS page. Now, what I have to do here is on this server, I just have to get my application files or my code onto the server. Once I do that, you can see this page also will change and whatever the website that I'll be having or that I wanted to show will be visible over here. Then this IP address, you can actually map it onto a name, which we call as a domain name, like for example, some Simply Cloud or whatever domain name that you have. To that, you will be able to map it. For that, you just have to configure a custom DNS. So once you configure a DNS, now you can type simplycloud.com. That will point to this particular website over here. Okay. So this is what we have setting up a basic VM. So what are the things that we have discussed today? We explained about the on-premises infrastructure. We moved on to virtualization. From there, we talked about what is a high-level virtualization or a highly virtualized environment, which we concluded with private cloud. And then from private cloud, we moved on to what is public cloud. And then in public cloud, we also did a couple of examples to see how a sample VM can be deployed. Okay.
So let's get started, and let's start from the ABC of MLOps. So MLOps is basically DevOps in machine learning. And what is DevOps? If you know DevOps, you can understand MLOps very easily, the concept or the theory behind it. How it is implemented, I'm going to show you all today. So total, we are going to have around 6 hours of class around MLOps, in which the objective is we will be deploying a machine learning model in Azure. So how we will deploy it, I will take you from start to end, and let's bear with me for this entire journey. So those who know DevOps, they know that DevOps main role is to make developers' life easier and to provide a platform where we can have a continuous build and deployment cycle. So DevOps for machine learning models, often called MLOps, is a process for developing models for production. A model's life cycle from training to deployment must be auditable, if not reproducible. So far you have been developing machine learning models in your Jupyter notebook, but that's not how you do deployment. In order to do the deployment, you need to upload your code or your model on a cloud platform. What are those cloud platforms? Those cloud platforms are Azure or AWS and Google Cloud that I talked about. How exactly it functions? So basically, your model needs to be some kind of a Python script or a Jupyter notebook. That model needs to reference or read the data. Then that model is deployed in form of a pipeline, and there should be a way to monitor your model and a way to analyze its performance and retrain the model. Once you have all these things in place, you are basically covering MLOps. Once you have a setup with which you can train your model, you can deploy model at a place, you can monitor your model, and you can analyze performance and retrain the model. If you can develop this setup, you are good to go for any machine learning changes that you will make. Then for MLOps, there are many platforms. Let's read about the set of practices first. So as a practice, it collaborates and communicates between data scientists and operations professionals. Applying these practices increase the quality, simplifies the management process, and automates the deployment of machine learning and deep learning models in large-scale production environment. It's easier to align models with business needs as well as regulatory requirement. Many times when we need to make a change in our ML model, depending on the regulatory requirement, having an MLOps setup makes it easier to bring that change in the deployed model. Also, when we need to change the data, we have a better place or everything is parameterized or optimized. So why do we need MLOps? So as a machine learning or as a machine learning engineer or as a data scientist, you basically help individuals and businesses deploy solutions that unlock previously untapped sources of revenue, save time, and reduce cost. But every model has a life cycle, and uh, many times you cannot host or deploy the model on your local machine. You need to host it at a place where the model can be maintained by a set of people, generally data engineers, other data scientists, or program managers, who can see how exactly the data shift or data changing over time can ops means operations. Data changing over time can be accounted for by the machine learning model. MLOps basically serves this purpose. It provides us a faster go-to-market and operational cost in deploying the model. It also allows us to handle more, the issues that happens due to data shift or data's quality degradation over time or change over time. It allows us to monitor such issues and stay on top of it always. Also, in case of need to change the model, MLOps allows us or makes it very easier to change the underlying model with which we are making prediction. So model governance issues is solved with MLOps. What are the processes involved in MLOps? So the complete MLOps process is divided into three broad phases. First is designing, second is model development, and third is operations. Designing is where we basically go to market means, yes, go to market means real-time production deployment of machine learning model. So far, you have done classification, regression clustering in Jupyter Notebook, be it in Colab or be it in your local. But right now, we are going to deal with real deployment of machine learning model. Great. So the complete MLOps process gets divided into three broad categories. Design, it is where we do the requirement engineering. We do ML use case prioritization, and we check for data availability. Once we have all these three things in place, we design the architecture in which we will be deploying our machine learning model. Then comes model development state. In this, we do data engineering, we do ML model engineering, we do model test and validation. Once these two are also complete in the data science life cycle, we reach the state of ML ops, which is the third state. In the operation step, we do ML model deployment, and this deployment happens through CI/CD pipeline, and we do monitoring and tagging. Now, how exactly we define or we design the process of MLOps? The first phase is devoted to business understanding, data understanding, and designing ML powered software. So, in the first phase, CI/CD, Google it, standard term, which basically means continuous integration and continuous delivery. So in the first phase, it is devoted to business understanding, data understanding, and designing the ML-powered software. In this state, we identify our potential user, design the machine learning solution to solve its problem, and assess the further development of the project. Mostly, what we do here, we act between the two category of problems, either increasing the productivity of the user or increasing the interactivity of our application. And initially, we define ML use case and prioritize them. Best practice for ML project is to generally work on one ML use case at a time. And furthermore, design phases aim to inspect the available data that will be needed to train our model and to specify the functional and non-functional requirement of our ML model. For this, we should always use the requirements to design the architecture of ML application, establish the survey strategies, and create a test suite for the future ML models. All these things sounds very, theoretical or bookish, right? I will make it all real to you. Don't worry. Just follow it here, have these terminologies and have these ideas or concepts in your head. ML powered software, it's basically means ML solution. So say for example, you have a platform which predicts housing prices or Boston housing prices. That software which is capable of predicting housing prices needs to have an underlying machine learning regression module that is ML powered software. So if you make a software that uses machine learning, it is ML powered software. Is that again Python code? Yes. So your software can be a React framework with one stage of Python code where machine learning is applied. Great. Then comes the second stage, model development. In this stage, what you do is you basically do a proof of concept of your machine learning model. How you do proof of concept? You build that machine learning model in your local machine. You use the data, small size that is available to you. You run several iteration and you decide which algorithm or which way of learning works best. So in general, if you guys have read so far in the past, there are different kind of machine learning models. Similar classification you can do using decision tree, you can do random forest, you can do XGBoost. And you have also learned that advanced models or complex models like XGBoost, they work better in their learning from the same data set compared to decision tree, which is relatively a simpler way of learning from the data. Such iterations or such identification or proof of concept we do in our local machine, and we do with small amount of data set. Again, data engineers are involved, model engineers are involved, and we come up with a solution that will do prediction or that will do insight generation. But that model is not good for deployment in production. Where is This is where the last stage or MLOps comes into picture, which is the operations or model deployment. Am I clear, guys, so far? Are you able to follow me? Is the voice still bad? Okay, too fast. All right, great. Wasim, so basically, I was explaining what MLOps is. It's the theoretical part, and hence I'm going fast. If you want to understand the theory, so far, these two slides are important. The first slide is where I'm explaining what the MLOps process is. Here, this is your entire model deployment process where you have data set, you train your model, you deploy the model, you monitor your model continuously, you analyze performance, and if needed, you retrain the model, and you update the data once you make prediction. And you again, train your model on the updated data. How exactly this cycle happens? So on your prediction, business takes some action. When business takes some action, your data is not the same. It becomes different. So your model also needs to adapt to the change.
Just a quick info, guys. If you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
Is this line clear? The last line that I said to you guys, what is model here? Model is Python script, Sakib. Your Python script. It can be any model. It can be a linear regression model, logistic model, or it can be for any use case. Now, let me make it clear by giving you an example. Okay, suppose you are a business and your business is to sell insurance, and you basically have a sales force of 1,000 salesmen who are selling insurance, and you have a customer of say 5 lakh customers. Now, with those 1,000 salesmen, how will you address 5 lakh customer? One salesman will have how many customers? 50 customers. So how will you make the life easier for them? You can tell every salesman which customer you can target, who are at the maximum risk of converting. It's a basic machine learning model of classification. And you want to classify out of 5 lakh people, which people have highest affinity to buy your insurance. Correct? So what you do, you train a classification model, you learn from the data of 5 lakh people, you train a model, and you deploy the model. How you deploy it? You deploy it in Azure. You cannot deploy it in your local machine, like Google Colab or your local, computer where you are running Jupyter. You need to deploy it in a place where you can continuously iterate the model if needed, where the data size can be huge, where you have huge computational capability, where other data scientists can also work, where you can schedule the model run or this entire pipeline run. So you deploy it on some platform on cloud like Azure or Google. You can do the deployment in your local machine as well. CI/CD with Maven, Jenkins, etc. No, not needed. It's very easy. You can monitor it and you can analyze the performance and retrain the model. So this is the entire flow. Now, your entire machine learning step is divided into 3 parts: your design step, your model development step, and deployment step, or the operation step. In design step, what you do, you go and check what all features are there, what all data is there, what is your business problem. Then you do what? You come to second stage, you develop your model, and finally you do what? You deploy your model once you have tested. This is what I was explaining so far. So finally comes operations, right? In operations, the main focus is to deliver previously developed ML model in production using DevOps practices such as testing, versioning, continuous delivery, and monitoring. All three phases are interconnected and influenced by each other. For example, during the design phase, you may have a data set which you are not considering. So that change, if you will make, that will be propagating into experimentation phase. And finally, that will influence the deployment phase. Say, for example, during the design phase, you have only taken, say, for example, 6 or 5 features. So you don't be needing a very powerful machine that can process, say, for example, 128 GB of data at once. But if during the design phase only you have taken 200 features and your data set is like more than billions record, of record, then you will need a very powerful compute, and even 128 GB will not be sufficient for you. So during design phase, you need to be very careful of what exactly will be your solution in the operations phase. So each phase are influenced by each other. So this is the last line. Then comes understanding of ML pipelines. So this entire thing, the entire package which you see here, from data to training model, to deploying model, to monitoring, to analyzing performance and retraining the model and updating the data, it is a part of machine learning pipeline. It is called a pipeline or an ML pipeline. We can make such pipelines in Azure ML. This is what we are going to learn. Are you guys excited? Great. So I hope you people are already familiar with creating accounts on Azure. So let me also start sharing my screen. Azure portal. Guys, you can follow. Whatever I'm doing, you guys can follow and do it together with me. So I need to sign in with my account, free account, and I'm going to build it from scratch for you. You guys will see the deployment from scratch. Guys, so for this, we need resources. What are resources we need? We need Azure ML. So when you come to home and you see your Azure uh, screen, it will somewhat looks like this. So I get around 10,000 credits every month for using Azure. This is for Microsoft employees. So you guys will have a free subscription, I guess, and you people will also have $100 allocated. So understanding ML pipelines, basically ML pipeline is a portable and scalable ML workflow, which is based on containers. ML pipelines are composed of several input parameter and a list of tasks. Each task is an instance of a pipeline component, and we can apply MLOps strategies to automate repeatable processes, experiment by running an ML workflow with different set of hyperparameter, number of training steps or iterations, and we can reuse a pipeline's workflow to train new models as well. So all these happen through ML pipeline. I'm going to tell you how exactly we can make a pipeline. What all pipeline components exist? Pipeline components, first of all, what exactly are these pipeline components? So guys, when you think of ML pipeline, right, think of it as end-to-end solution where you have all these things packaged together. You write from your data to your Python script where your model is present, to the deployment of the model, to the way to monitor your model and scheduling and running it, to analyzing its performance and retraining it if needed, and finally updating the data. So think of pipeline as a sequence of all these steps. Everything that you can do in in a model development lifecycle is put together in a machine learning pipeline. What is your model development life cycle? Your model development life cycle, again, I'm repeating, consists of three steps: designing, development, and delivery, which is the deployment. Is it clear? Cool. So we deploy a pipeline with all these MLOps strategies, and if needed, we can also tune the hyperparameter, and we can iterate the workflow of the training of the model. Now, a pipeline has several components. What all components it has? Pipeline components are self-contained set of codes that perform one step in a pipeline workflow. It can be a data processing component, it can be a data transformation component, it can be a model training component, yada, yada, yada. It's up to the designer of the pipeline to decide how exactly he will be designing the pipeline. These components are composed of set of input parameters or a set of outputs and the location of a container image. A components container image is basically a package that includes components executable code and a definition of the environment that the code is run on. These two lines are very important, guys, and I will be explaining it to you how to do this later in the hands-on part of the session. Now, what is hyperparameter tuning? So hyperparameter tuning is the way by which you can change the parameters that with which your model is learned or tuned or trained. Hyperparameters are specified when we are training the model. And usually when training the model, the training application handles three types of data. It handles input data, it handles different model parameters, and it also handles hyperparameters. Hyperparameters are what these are the configurable variables that goes during the time of training the job. So when during training, hyperparameters stay same, input data keeps on changing, model parameter also stays same when working on similar data. Now, how hyperparameter tuning works? Hyperparameter tuning works by running multiple trials in a single training job. Each trial, you complete execution for the value of the chosen hyperparameter. Have you guys done hyperparameter tuning when doing classification, regression, etc.? Oh, amazing. Then how come classification and all these are over? This is one of the step in machine learning too. And that's why I'm rushing through it, because I know you guys already know it. Oh, amazing. Wait. So I'm not prepared for it, but let me explain in a more real way by which you can connect how hyperparameter tuning works. Guys, this is very important. Hyperparameter tuning is very important. Let me open kaggle.com. Oh, let me search hyperparameter tuning. Real model. Cool. I have one. Exactly, exactly. So when you tune the hyperparameter, right, you change or you pass through a set of different parameters with which your model will learn from the data. And there are effective ways by which you can do hyperparameter tuning. Have you learned about n-fold validation, k-fold validation? Yes, perfect. Yeah, exactly. That's how you do hyperparameter tuning. Correct, 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 correct. So you try out with different parameters for your model and you do a cross validation and you choose the parameter which is the best one for your model. And that's it. Voila. Okay, fine. But ideally, there are multiple models. Using k-fold validation, right? What you do is you minimize the bias and the variance that will happen in your model's learning. Correct. So this is one tutorial for hyperparameter tuning. I'm sharing it with you guys. Learn it later. Else I will have to, explain hyperparameter tuning to you guys. Cool. So hyperparameter tuning is one very essential step in a machine learning workflow or pipeline because our data underlying keeps on changing over time. And it's also a terminology. It's called model shift. Sorry, it's called data shift. Data shift in machine learning. Search about this. Those people who are very familiar, who are into machine learning, they understand what is a data shift, data set shift. So over time, your data's behavior changes, or your underlying data only becomes very different. Say, for example, you created a machine learning model to predict Boston's housing prices. Do you think after 1 year, the same logic that the model has learned is going to work in the market for predicting house price? No, right? Economy changes, the world moves, the world becomes very different, currency value changes, everything goes different, and hence your underlying data set only goes shifted, gets shifted. And this is a very common term in machine learning paradigm. It's called data set shift. Yes, exactly. It doesn't happen every time, but over a period of time it does change. Yeah, over a period of time it does change. So you need to make a correction for it. How do you correct for it? So you retrain your model, or you optimize the hyperparameter with which you have trained your model. And this is what I was implying by hyperparameter tuning. So with hyperparameter tuning, you change the way your model has learned the decision boundary. And when you account for that change, you account for the data that got shifted over time. Okay, so let me again come back. So hyperparameter tuning works by running multiple trials on a single training job. So you start with a set of parameters. Say, for example, when you are implementing decision tree, you are saying that, hey, you know what, implement a D tree with a maximum depth of say 30, right? And you train or you do k-fold validation with 30 depth. Then you change the parameter and you make it, instead of 30 depth, make it 50 depth. Similarly, you make it 100 depth or you make it 80 depth, and you keep on doing n-fold validation. And you pick the one that has, pick the depth one, which has got the best accuracy on the cross validation set. Each trial is a complete execution of your training application with values for your chosen hyperparameter set within limits you specify. So here, what I have specified in the example I gave for decision tree, I specify the depth of my tree, whether it's going to be 30 or 50 or 80 or 100. When the job is finished, you can get a summary of all the trials along with the most effective configuration of values according to the criteria that you have specified. Hyperparameter optimization or tuning can be a tedious task, but with Azure Machine Learning, you can automate this task for arbitrary parameterized command with little modification to your job definition. And you can visualize the results in the studio as well. Now, what is Azure Machine Learning? This is where I wanted you guys to, see and become familiar with Azure's platform. So Azure Machine Learning is Azure's offering to enable, all these MLOps best practices and to allow for model deployment, in Azure. So this icon of Azure machine learning looks like this. Hyperparameter, yeah, because it's a parameter with which you are training your model. You can specify a number range, and you can also, and it cannot be a number, it can also be a fixed value. Say, for example, in many of the models that you are training for what were the name? Yeah, all the for all the boosting model, there are parameters that are not numbers. You can also have parameters which are, the values. All right. So it's not necessarily be numbers all the time. Hyperparameter can also be a string from all the possible option of strings which the model accepts during training. Say, for example, you are fitting uh, a distribution. So you can specify from a list of strings which distribution to fit. Okay. Say, for example, you have a distribution and you want to fit, linear, you want to fit Gaussian, you want to fit V-bull. So you can even specify such strings as parameters. Yeah, I mean, either you can increase or decrease. You can start from maximum, or you can do that. It's up to you. This is called you're descending. So there is a step in every machine learning project where you do hyperparameter tuning. This step is called hyperparameter tuning. What is hyperparameter tuning in machine learning? Just search for it. Let me show you a workbook or a tutorial. Yeah, analytics Vidya. There is a blog. See, so you perform hyperparameter search over a grid. It's called grid. So all the values that you have applied, right? Okay, what is the difference between GitHub and Azure? So Azure is a platform. So Azure is an offering which encompasses multiple products under it. So if you go to Azure subscription or Azure portal, there are n number of things inside. You can have a Kubernetes service, you can have a storage account, you can have a Databricks account, you can have a key vault, you can have a VM that you can commission, you can have a Databricks, resource group, you can have a Azure Data Explorer cluster, you can do n number of things inside. You name something, it will be there in Azure. What do you want? What do you want? You work on Red Hat, just search for Red Hat, right? There will be something for Red Hat. You have a Linux machine for Red Hat that you can commission or you can purchase for yourself. You can create a Linux Red Hat SAP business apps on Azure. So Azure is end-to-end offering that encompasses multiple platforms and multiple softwares which you can host on Microsoft's cloud. And this entire offering is called Azure. You can host a Kubernetes service, you can host a Elastic Cloud, you can host a single VM, you can host a Azure command line interface packed with Bitnami, whatever. What is GitHub? GitHub is a version control something. Uh, you know, yeah, let's check what is GitHub. GitHub is a version control tool as far as I know. What is GitHub? Oh, what is this? GitHub. Yeah, so it's a build software, mostly used for version controlling. Yep, it is used for managing your Git repositories that helps developers manage, track, and control. Let's again get back to our discussion. We were talking about Azure machine learning, right? So Azure machine learning is the cloud offering of Microsoft, and it allows for machine learning related, platform as a service. So it allows for machine learning related project lifecycle management, and all the machine learning professionals, data scientists, and engineers, they can use it in their day-to-day workflow to train and deploy models and perform MLOps. Using this, you can also create a model in Azure Machine Learning, and you can use it to build models from any open source platform such as PyTorch, TensorFlow, or Scikit-learn. So we are going to see all these things. We are going to see how we can make a model in Azure Machine Learning. So today, let's not go to deployment part immediately. Let's get familiar with Azure Machine Learning. What all components are there in Azure Machine Learning, and see how we can do development in Azure Machine Learning. That will be a good objective for today, and let's aim for it. So it will look something like this, guys. And this is basically your project lifecycle. Your ML project lifecycle can vary depending on your project, but a common cycle will involve defining the task, doing some data exploration, training and validating the model, deploying the model, and MLOps, which is monitoring and managing the lifecycle of the model. So all these things we are going to do on Azure ML Studio. Azure ML Studio will look like this somewhat. But before I introduce you here, let me show you a real one. Here, let's start by first logging into Azure. So for logging into Azure, in your web browser, type this URL, portal.azure.com. If you have not sign in and create an account. In the first trial, you will get, I think, $100 or $10, which you can use for your familiarity, getting familiarity and performing some basic experiments like what we are going to do today in Azure. And you can create multiple accounts, guys. Once you reach here, you need to create a resource. Now here, type machine learning. The moment I will type machine learning, I will automatically get a suggestion of creating Azure machine learning. No, it's not 30 days. Oh, yeah. Are you saying for me, for Microsoft employees? I mean, I don't know, dude. We get it every month. Oh, okay. No, no, no. It's one time $200, not for uh, everyone. I think it's only one time, $200 for 30 days, not for 30 days. It's one time. There is no time limit that it will renew after 30 days. Okay, great. Log in. Once you log in, hey Vaishnavi, are you here? Are you able to follow this? Guys, is everyone able to log in to Azure portal? Perfect. Okay, fine. The next thing or the next step, click on create a resource. Okay. Search first for blob storage. No, not this one. Search for storage account and commission a storage account. Click on create. Choose a subscription. Choose a resource group. Oh, wait. Before this, here I will use test group. I will use Visual Studio Enterprise subscription. And I will name my account as Blob Store Intellipaat. Okay. The reason I will select West US. Guys, a tip, always select West US. This storage is where I will save my CSV files or the data on which I will do the training. That's why I'm creating this blob store. Performance select standard and redundancy, make it geo storage. Then click on next, 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 click on review. Yeah. Oh, I think I need to change something. It is running final validation. Just wait for it to complete. And finally, click on create. So first, what did I create? I created a storage account. Be clear about it. And I want you guys also. No, 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 don't choose Central India. The problem is all the time, not every Azure resource will be available globally. How to create a resource group? Just type for resource group. Or when you guys will be creating your account for the first time, it will automatically prompt you to create a resource group as well. So search for storage account, and there only you guys can see a resource group created. So this is my blob store Intellipaat. I am pinning it on my dashboard. Okay. Similarly, create a resource group, and once you create your storage account, it will look something like this. Then how can we use Azure? Once you create it, you start using Azure, and you need to fetch something. So think of Azure, right? Redundancy should be GRS or nothing matters. Just go ahead, select what was default. You already created a subscription. Okay, fine. Yeah, so once you create a storage account from the steps which I showed, 7th of August, I have a subscription. So guys, you can create a free storage or free trial account, but make sure that you cancel it after the subscription or after you have reached the time period when it is going to renew, because this actually costs a lot. So one fine day you will be charged 10,000 rupees out of nowhere. So please cancel it. Great. So once you do that, create a storage account. I have created one for demonstration. It's called Blob Store Intellipaat. Now, inside this, containers is where we will save our file. So we will create a new container and we will call data for model training. All right, perfect. All right, okay, I cannot use underscore and I will click on create. So one container is created for me. Now what I'm going to do is I'm going to upload some CSV file from the container in the container. Now where I will get the CSV file? Let's use one CSV file that I have. Say for example, do I have a good CSV file? Let me check my downloads and let me check documents and let me check for Kaggle. Do I have Kaggle something? No? Okay. I need to check downloads. I need to check for Kaggle. No, I don't see anything related to Kaggle here. In case data is not coming for flat file, but it will still be a text data, you can read it. Wait, I am downloading a Kaggle CSV project. Oh yeah, you can do that as well. In case of flat files, it's easy, but not a flat file. It should be somewhere in Azure. It should be somewhere in Azure. So say for example, you will have a data storage, right? So search for data store. There are Azure Cosmos DB. You can link it to Azure Cosmos DB. Or a SQL server. You can have a SQL server in Azure. SQL databases. You can have your SQL servers or SQL databases as a service in Azure. Load your data here in the SQL database and you can read it back. Or in case of complexity, there is another Azure tool called Azure Data Factory. So you use or you orchestrate your entire job using Azure Data Factory, also known as Azure Data Explorer. So you can create a new Azure Data Explorer pipeline that will integrate migrating your file from SQL Server to a CSV on the blob store as a flat file. And from there, you can read it inside your Azure ML pipeline. So I'm going to explain what all things, what all type of data you can read in Azure ML pipeline. But let's first get familiar. I'm starting with sharing, the details around what is a blob store. And in containers, I created a new container, which was data for training. And here I need a flat file, a CSV file. So let me use Boston housing data, or let's be very simple. Okay, let's use Titanic data, Kaggle Titanic prediction. So I'm using Kaggle Titanic prediction data. So machine learning from disaster, and let me download the data set so that I can push it on there. Okay, where to download the data? Download all. Great. Perfect. So I am downloading it in documents, titanic.zip. It got downloaded. Let me extract it. Control C. And I'm pasting it in desktop for now. Oh, did it got control copied? I'm not able to extract it. What the hell? Yeah, here. Okay, fine. So I have train test. Please ping this link. Great. Okay. So download the data from here. You need to log into Kaggle as well, guys. So log into Kaggle, download this data set. Once you have downloaded it, I will be uploading it. Okay. So let me upload. And I will upload these files. What was the name? Train, test, and that's it. Open. And I will click on upload. The moment I will click on upload, it will upload my data as a flat file in the container on the blob store. So this is your blob store. And now your data or your CSV is present here. So let's also get started with Azure Machine Learning. So what you need to do, guys, you need to click on create a resource and you need to search for machine learning. When you will search for machine learning, you will automatically get Azure Machine Learning. This is what we need. And let me again click on chat so that I can see everyone. And let's click on create. The moment you will click on create, you need to again fill all these things. So DevOps is, MLOps is a subset of DevOps, which basically involves applying the same DevOps principles to machine learning paradigm and for, continuous build, deployment, training of machine learning model. DevOps is the bigger field, which is mostly for software engineering, and it involves using CI/CD pipelines to ensure continuous deployment of builds of softwares and ensure version control and other challenges which is involved in software development and maintenance. Okay, I'm again selecting a resource group, so I'm using test group and workspace name. So this is very important. What do you want to call your Azure machine learning workspace? So I will call it Intellipaat demos. Okay, Intellipaat demos. Cool. I will select West US. Guys, it's a secret tip from somebody working in Microsoft. Use West US. Storage account is already chosen. Intellipaat demo that we created. Keyword Intellipaat demo that I have already created. Application insights, container registry. Oh, I need to select something.
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
Wait, let's try without it. None. And let's click on review and create. So it is running final validation. Perfect, I can create it. So let's click on create. This is your machine learning studio. Again, it's an offering of Azure. It's not like you cannot run your notebooks at any other place. You have another offering called Azure Synapse. Let's try that. So see, deployment is in progress. It will take around 1 minute to deploy. Let's wait for it. There is another offering similar to it called Azure Synapse. It's called Azure Synapse Analytics. You can again create workspace in Synapse. Again, attach it to a resource group. I am attaching it to test group. Workspace name is Synapse demo. Okay, it only contains lowercase letter. So let's call it Synapse demo. I'm again choosing, okay, Intellipaat. Then I'm going to, okay, cool, Azure's with the selected subscription. Oh, Synapse is difficult. I need to register it again. Check Synapse. Let's focus only on Azure ML. So my deployment is in progress. Okay, fine. It got deployed here. So let's click on go to resource. So I have Azure ML notebook created. Yeah, Synapse is basically end-to-end integration of Azure machine learning pipeline with different data sets. So you can use Synapse for all the Git version control. At the same time, you can use it for development and your Power BI connectors to connect to your Power BI reports. It's like complete solution, right from fetching data to writing a notebook to pushing the data output to Power BI and scheduling and other things. With Azure ML, you can make machine learning pipelines, but the data migration side needs to be handled with another service, which is Azure Data Explorer, ADE. So with this, you need to do all the data migration. So yeah, this is the difference. With Azure machine learning, you can create and train and deploy ML models, but a step that connects the output to Power BI dashboard and a step which connects it to reading the data in Cosmos DB is missing. It can read from 3 places. I'm going to tell you what all places. Let's log into our ML workspace. So when you create an ML workspace, it looks something like this. You have subscription ID, you have test groups and other things defined. Here is your ML workspace. Whoa, nice. And it is going to ask you some basic questions. I am not going to answer. So this is my ML Studio. When you will launch it, you will come here first time. It is going to tell you what exactly you can do with ML Studio. And you can create or register your data, you can train your models, you can evaluate your models, and you can deploy your models. And we don't need the tool. This is how your ML Studio will look like. Here exactly is your subscription and workspace. So this is my subscription. If you remember, when I created it, I used Visual Studio Enterprise subscription. My default directory was default directory, and I use Intellipaat demos as the workspace, right? The resource group was text group, and the location was West US. I can also download the config file. Let's do that later. Here is my user ID. I'm logged in with ankitanma@outlook.com. And what all I have any notification coming here, right? I have settings coming here. I can change the mode to light mode, dark mode, whatever. And how you should interpret or understand Azure is basically you have a pane on your left, and this pane basically gets divided into different segments. So here you see it is divided into 4 segments. First is your home, which will bring you here, the first page or the default page. Second is your author segment. Third is your asset segment. So you first need to create your Azure ML workspace. All right. Once you do machine learning. So guys, for people who are following me or even Yagnesh, this is how your any Azure resource is organized. Even your storage account. Let me again go back. So even the storage account, which is Blob Intellipaat, which I open, it is organized into same way. See, it is divided into so many different sections. First is your overview, then comes second section, which is data storage. These sections basically allows you to do things around data storage inside storage account. Then you have security plus networking, and it has all the access keys and yada 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 yada. Then you have a data management section. Then you have settings section. Similarly, in Azure Machine Learning Studio, you have these sections. You have author section, where you can author a machine learning pipeline. There are 3 ways of authoring, and I will tell you each way one by one. Then you have assets section. And what all assets you have? You have assets in form of your data, in form of your machine learning jobs, in form of your components, machine learning components that are reusable piece of code in machine learning world. They are called components inside Azure. Then you have machine learning pipeline. This is what we are trying to build. I was talking about pipelines here, right? In the PPT. We are trying to build the same pipeline. Remember, we are talking about pipelines, understanding machine learning pipelines. That same machine learning pipeline is what we will build here, this pipelines. All right. Then we have environments. Environments are basically the variables, the clusters where you want to run, which Python version it will load, all these things pre-packaged and created. Right, so you can create such curated environment. You can even read or load certain already created environment for you. Like we have PyTorch environment, we have TensorFlow environment. So Azure by default gives you such environment, or you can even create your own. It's up to you. All right, where was I? Then pipelines, environment, then what? Then endpoints and compute. Compute is important. Compute basically is the machine or CPU in which you will run your code. So say, for example, when we will when we run a Jupyter notebook in our local machine, we already have our processor attached to it. But when you create a new notebook or even author a notebook, you need to have a machine on which your code will run. So you can purchase machines from here. You can purchase a cluster, you can purchase a single machine, and you can also have attached computes from your Kubernetes service or a VM that you have commissioned. So even you can use that. So you can attach a Kubernetes cluster, you can use a Azure Databricks VM, you can use Synapse Spark Pool, or you can even use virtual machine. So I have already created a VM. I can use that, right? So all these things are possible. Are you able to follow till now, guys? I'm just explaining how Azure ML flow looks like. Perfect. Cool. So again, I come back to home. So yeah, let's see what all things I can do. The moment I click on new, it is asking me what I want to make. Do I want to make a data store? Do I want to do a data labeling project? Do I want to make a training cluster, compute instance, model? What exactly? Or a job, right? Job is present in preview right now. So let's do, or do I want to have a link service or something? Let's again get back to the PPT and see what all things they have explained here. So we understood that we are interested in making a pipeline or a machine learning pipeline. What a machine learning pipeline does, it has got all these steps inside. It reads data. We have already saved our data on Blob Store in train.csv. Then it trains a model. It then deploys the model. it monitors the model, analyzes, and updates the data. So how we will train the model? We will have a Python script. We will do that. Don't worry about it. Then we need to do all these things. So the offering which allows us in Azure to do all these steps or make a pipeline is Azure Machine Learning. We just got familiar with the icon here when I showed you AML, the first page. Yeah, you see the favicon of this tab. It's Azure Machine Learning, correct? Okay, so we just got familiar. Now we're all inside Azure Machine Learning. So things inside Azure Machine Learning is basically it allows us to manage all these project lifecycle. And this is our studio. When we will log in here, it looks like this. Inside this, we use notebooks. So notebooks is where we will use and we will create our first Jupyter notebook. There are ways by which we can use auto-created or auto-trained models too. It is using automated ML. Automated ML allows us to use pre-trained models to, to perform subtasks. Designer is another easy way to make a model using drag and drop feature. We are not going to use designer now. Maybe I'm going to teach you later if time permits. But for now, let's create a new Jupyter notebook here in Azure ML Studio by clicking on notebooks. People who are following me or who are doing it along with me, are you able to follow so far? I want to know how many people are doing this with me. Uh, those who are doing this with me, say yes. Amazing. Yeah, proper developer life. Okay, so I will click on plus sign. And those who are working or who already have Google Colab notebooks, click on upload files. And you can directly upload it. All right, guys? So that's it. It's just simple. And click on plus and you can upload your file, whichever file you have right here. And that file will be hosted. So I do have some files. Let me use that. Yeah. Wait, where are those files? Yep. ML pipeline notebook 2.py. Okay. You need to click on I trust the content of this file and you need to click on upload. This way, your file will get uploaded. All right. And now you see things appear here in Jupyter Notebook. Isn't it interesting? Right? See, this is your Jupyter Notebook. But you cannot run it straight away. Why? Because you need a compute. And I also need helper files to, not basically read the code from scratch. So I have already done a lot of ML development in these ML pipelines. So let me use that. Prod code AML, Teams pipeline notebook, workload. Let's use that. Oh, wait. Yep. Okay. Let me upload it. So here I have done two things. You see there is a IPython notebook, which is your Jupyter notebook. At the same time, you can also run your Python scripts too, right? So these two things, even your Python code you can run, but all these things, all these development happen inside notebook. So I will use it later. But the first thing is you need to create a compute. So those who are following me or who are working with me, click on compute. Once you click on compute, here, select compute instance and not compute cluster. You can create a compute cluster as well, but compute instance is good for light use. Here, type a name of your computer. This will be your machine name with which your machine. So let me name my computer as best computer. Okay. Or whatever you want to name. It should be location will be West US and you can choose between set of all options. And guys, be very careful. Every hour you run it, you will incur a cost. And how much cost I have, how much budget I had around 10,800 rupees. And this cost is not in rupees anymore, it's in dollars. All right. So be very careful. So for demo purpose, I will use two computes. One is a sasta wala compute or a cheap compute that has 14 GB RAM, 100 GB storage, 2 cores. Okay, this is too cheap. Let's use a better one. Let's use a better one. Let's use 28 GB at least. No, 4 GB storage is very less. 32 GB. Okay. 32 GB RAM, 64 GB storage, and perfect. And I will click on create. This is one of my compute, which is getting commissioned for me. The moment it will get commissioned, I will get to see. Guys, can you follow till here? In AWS, things are different. You need to create a EC2 instance and create an EMR cluster. Oh, yeah, the moment, very good question, because dollars are being wasted. So the moment you are done, you know, you are done coding and you are done building and deploying your pipeline, you can come here again, click on compute, select your compute and click on stop. So once you are done building or development or you're not working in your notebook, you can stop your compute. So right now it will take some time, around 5 minutes to commission the compute. Till then, I am preparing our notebook. All right. So again, I will go and I will click on plus and I will click on create a new file and I will call this as Titanic prediction.ipynb. Titanic underscore preds.ipynb. And I will create this file. We will use all the libraries. All the libraries. You can also install new libraries. I will show you how to install new library as well. Okay, so my compute is getting commissioned. Best compute creating. So those people who want to install a new library, you can use pip command. Let this code load. This is basically a Jupyter notebook, guys. It's very similar to how Jupyter notebook works, but you can use even Jupyter for running this. So let this connect to a compute. Let me commission the compute first. Then I will show you how exactly you can use Jupyter Notebook. Meanwhile, I also need to do some import steps. So let me copy those import steps from here. Let me also copy the basic ML codes. So these are standards. I'm going to paste it below in the chat too for everyone, for people to understand and read. Perfect. Okay. Still creating. What stages we are now in DDD model, design, develop, and deploy. We are in design. So we are still deciding the problem statement, what to do with Titanic data. And since we have opened our Jupyter notebook, and the moment we will start, we will be in develop, and then we will later be in deployment. So my compute got up and it is running. So I can see my compute, best computer, it is running. Perfect. Again, come back to notebook. The moment you will come back to notebook, I am sharing a few lines of code. Just copy it. Before, why not we get, yeah, it will ask you to authenticate as well. So click on authenticate. Again, select your account, or it will automatically log you in and return back to the same URL. Oh no, it is asking me to pick an account. I will select the account. Oh, why is it asking me again? Looks like it got stuck. Dude, it is asking me. It got stuck in a loop. Screen is not visible. Guys, who all can see my screen? Great. So I'm authenticated to Azure SDK. Now I'm copying some codes. Fine. So use these codes. Yeah, you can copy from Zoom text. So it's very difficult to figure out these steps. When I started in my team, I was tasked with doing this machine learning model deployment and development on Azure ML. So for me, it took around 15 days just to figure out these lines, like what exactly to write, where to write, what should be the value, how to get it, how to create the entire setup, how to familiarize myself with Azure ML. So I'm serving you already had ready-made things. It took me like, a proper 3 weeks to learn and set all these things up from scratch. So yeah, what is line 3 and line 4? Line 3 is workspace. Okay, so I'm explaining it to you. So if you will again go back to your machine learning, Azure machine learning, uh, Intellipaat demos, here you will see all the details, what exactly is here. You need to click on download config.json. So when you will click on config.json and you will download it, you will see everything, what all subscription you belong to and what all details you have. Your subscription ID is present here, Intellipaat demos. For me, my subscription ID is this, 56A, yada, 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 yada. So I will put this subscription ID. Subscription ID is basically your Azure subscriptions ID. Your resource group. What was my resource group? Again, my resource group was present here. Where exactly, I know? or I can know about my resource group. Yeah, it's test group. I can copy it. I can paste it. So you need to again go back to your first screen in Azure ML, and you need to keep pasting these things. What is my workspace? What is my workspace name? My workspace name is Intellipaat demos, right? So that is my workspace, Azure workspace. So let's copy this Intellipaat demos, and let me again put it. So in workspace name, I pasted this. Perfect. Then what I did, I am printing the workspace name was workspace resource group, location, subscription, yada, yada, yada. Then I want it to be pointed or be able to read CSV file from a blob store. Remember, we created a blob store. So I will again go back and I will open my blob store, which was Intellipaat, blob store Intellipaat. Okay, resource group. So resource group is basically uh, all these blob stores, Azure ML. It's a part of a resource group. So resource group, you assume, is basically a collection of multiple resources. Resources being your blob store or your Azure ML workspace or any other thing that you create inside. So all these things are your resource groups. So workspace basically is your Azure ML Studio workspace name. So that is your workspace. Can you just show this submit? Submit, what is submit? Subscription ID. Okay, fine. So for subscription ID, what you need to do is you open your workspace, Azure ML. I created it with the name Intellipaat demos, whatever name you created it. Inside this, you click on, you will see something called subscription ID, or better, you download config.json file. If you open this config.json file in Notepad, you can see sub ID here as well. See, so in this Notepad, your subscription ID is mentioned, your resource group is mentioned, your workspace name is mentioned. Just copy this. That's it. Great. So download this config.json. It will have all these things. You can easily copy it. I can also show you something around Blob Store because we need to connect it to the Blob Store so that we can read the files from here. So what are the things I need about Blob Store? Again, these details or these information that I'm showing you. What is your Blob data store name? So for us, our Blob data store name is Blob Store Intellipaat. So we will copy and we will paste it. This is our Blob Store name. Then we need to read our data from a container. Where exactly is our container? So inside this, click on containers, and data for training is our container name. Is it clear? So let's copy data for training and let's paste it, our blob container name. Then comes account key name. So we need to again get account name, blob account name. So what was our storage account name? Wait. Blob data store name. Oh, okay. Right. So we also need to create a data store. So how exactly you create a data store is before I even, create blob data store name and all these things, I need to create or link it to a data store. So just like we created a compute file, we also need to create a data store file. So what exactly you need to do is you need to click on data store. Guys, there are a lot of steps, but you need to do all these things. You need to follow it. So create a new data store and type your data store name. So let's name this demo store. Okay, so we'll call it demo store. Data store type is Azure Blob Storage. Subscription ID is from Azure subscription. Storage account is here. I will select Intellipaat demo account. Okay. Authentication type will be account key, and I need to provide or specify the account key. The question should be where I will get the account key. So again, go to your storage account, Blob Store Intellipaat. Here, click on access keys. Click on access keys and click on show and click on copy to clipboard. Click on hide again. Okay. Now, whatever key you copied, just paste it here. Control V. Once you copy and paste, just wait for a few seconds. Customers should not include personal data because whatever. Oh yeah, blob container name. I need to select container name is Azure ML. Wait. Yeah, blob store Intellipaat, and my container name will be data for training. And I selected it. Where to find account name? Account name. Where exactly is your account name? You have data store name. There is no account name, dude. Storage account is there. folks, let me again repeat, okay? So let me leave everything. Again, come back to the first screen and show things from the beginning to you. Deployment is actually difficult. It's not easy. We are actually deploying the model. We are not doing any rocket science. We are just doing drag and drop and assembling everything together. So let me again repeat what are the things I did. So I created, okay, fine. So let me go a bit slow. Only when you guys will say, then I will move ahead. So we have created notebook. You guys have created a new notebook. Great. So once you can also edit this in Jupyter. So this is one thing which I said that I will tell you later. So click here on these sandwich icon, click on editors and click on edit in Jupyter and click on continue. So your entire code will be edited in Jupyter. This is your Jupyter notebook, the environment that you all are familiar with, correct? So yeah, you can do this and you can run your code in Jupyter Notebook or build the development in your Jupyter Notebook. It will be connected to your compute at the backend. So you see Python 8 Azure ML. Cool. So for running this, you need internet connection because it is connected to Azure. All right. But again, yeah, here was our files. So I basically created a new notebook and I shared a few pieces of code to you. You just paste it. I also told you how to I also told you how to find these workspace IDs, resource groups, and workspace name. So that was clear. And that was by going into your subscription, which is your Intellipaat demos. And here you need to download config.json. When you download the config.json, you will open it. You will find all these details. Is it clear, guys? Perfect. Okay. Next is what we need to do is, are you happy seeing Jupyter Notebook? I know it is a comfort zone, even for me. Great. So then, yeah, true. So then what happens is we need to create a data store. So what we did is just like we created compute. Yes, this will be the fixed template to use every time. These are the steps. You just need to repeat it with a new code or write a code with a new CSV that will be your data. But these are the steps. These are fixed steps. And trust me, even by Azure tutorials, it's very difficult to figure out these steps. So I figured these steps out by by doing work, interacting with teams, asking them questions, all these things. So you can ask me questions, you can do what I'm doing, how I'm doing, and it will be easy for you in future. Give me a minute. So when I will click on data store, here is your data store name. Okay. But I have done this long time back, so I don't remember exactly. Let's try to experiment it. So let's name it demo store. Then choose data store type as Azure Blob Storage, but you can also use ADLS account. You can also use Azure SQL database. You can also use Azure MySQL database. So people who were asking me, can I use SQL database? Can I use yada, yada, yada? Can I use ADLS Gen 1, Gen 2? Yes, you can. You just need to register it. So I am using flat file. So yeah, we have already uploaded data in a blob store. So let's use that. Choose your subscription, same subscription. Storage account is your blob store Intellipaat. That's what I created it. And here my container, which is data for training, is already shown. So I will be selecting it. I will choose authentication type as account key. Never choose SaaS token, guys. And copy the account key. How will I copy the account key? So I will again go back. I will open my blob store Intellipaat and I will check for access keys. So here there will be one account key. I don't know, but SaaS token will not allow you to read CSV file. Authentication generally happens through access keys. So I will just show, I will copy, I will hide, and I will again go back here and I will paste my account key here. The moment I'm done pasting, it will show me a button called create. So I will create it. Now, my Azure Machine Learning Studio is linked to Azure Blob Storage, where my CSV file was present. And at the end, you will get a message like this: create successfully created data store. Correct? Cool. So demo store is present. Let's try. Let's go back again to our notebook and we will call it data blob store name as demo store. Let's try this. Blob container name. So what was our container name? Data for training. So again, I will go back to my blob store. I will go to containers and I will check what was the name that I have given to my container. Again, I'm going slow now. All right, guys. So we create a data store. First, you all create your data store and then tell me, okay, we have done this. Oh, okay. Great, guys. Cool. So I think people have done this. So again, we will need to know our container name. Our container name is data for training. So I will copy this where we have pasted where we have uploaded our CSVs. I will again go here and I will paste container name as data for training. Then what is my blob account name? What was my blob account name? So again, blob account name is blob store Intellipaat. This is our storage account name. So I will again come back here and I will paste my blob account name. And it is also asking for account key. So how will I get the account key? I will go and use the access keys. I will click on show, copy it immediately, click on hide, and I will paste it as my account key. Cool. Enough things done. Let's run this. Okay. I ran the first line. So let's see. Data pipeline run is here. Yeah, you can use any of those, Wasim. Then I'm running the second line. I hope it doesn't throw me error.
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
Perfect. Perfect. It is printing. It didn't throw any error. Now I am fetching the data store, which is the third line or the third block. Okay. Wait. This is not the name of my data store. My data store name was what? It was demo store. So I will again type demo store and I will use control enter. Perfect. So I am connected to demo store. Amazing. So now I am in demo store. Now the first task is to read a Python file. How exactly we can read a Python file? Again, I need to go back, go to notebook, and I need to show you how to read a Python file. So for this, I am again using the code and I am telling you how to read a Python file. So the way is you do this, Control C, and I'm coming back here. I'm pasting it. Okay. So type this. So read your training data is equal to data set. We imported data set before, did we? Yeah, we did. So from Azure ML Core, we imported Workspace, dataset, and data store. So import dataset and type dot. It's a tabular data. So we will type tabular. We will type from delimited, from underscore delimited underscore files. And we will specify path is equal to, and here we will write in the bracket data store, store, comma, and I will specify the file name. What is my file name? My file name is again, go to the containers. Okay, I will share the other file which I will create. I will share. So train.csv. So my file name is train.csv. So done. Let's read this. So the moment I run this, it is referencing the container, which is the blob store, where I have the CSV. And voila, it read. So if I do and do a head and do 5, what exactly is this? Oh, okay. I also need to type a few things. Dot two pandas data frame. Then I can read it. Then it becomes a pandas data frame. So I read it again. Now if I do dot head and 5, here is my CSV file. Is it clear, guys? This is how you read or you invoke Jupyter Notebook and read data in Jupyter Notebook in Azure ML. Alrighty, so this is how you write or read data in Azure ML. Now, post this, develop this as a normal model development. Treat this as a normal model development project. Write your model, and then we will later do magic. So while you guys are doing it, let me again implement a basic model in this. So I'm going to use Titanic and a sample code here to basically build a model for everybody's reference later. Are you able to follow till here? You guys understood, right? You can also save your notebook by clicking on save checkpoint. Yep, amazing. Thanks. So now treat it as a normal model. Yeah, definitely you guys need to revise. Treat it as a normal model. This exactly is how deployment happens in Azure ML. So you need to, you need to learn this. There are other two stages as well, automated ML and designer. Designer is drag and drop. So you can use it to build pipelines by drag and drop. So drag and drop here, you can make a very basic model by dragging things. So say for example, I want to use data. So click on data. There will be many data-based, data sets already present. So you can use, any such data to do some information or run any model. So let's use weather data set. On this, there is a data output. So here you can, use a model, say linear regression. So what are linear models you have? Linear is not the identified keyword. Let's use component, and in component, let's use data. Do I have any data component? Yeah, you can use import data as a component. Import data will also allow you to import the data. So let's remove the data set. Guys, this is another thing. I'm showing you another possible way of building machine learning pipeline. So this is import data. Here you have parameters. So you can specify what will be your parameter. I generally don't use it. It's a very, trivial way of making pipelines. It's good for people who don't know machine learning. But since we know and we have already cracked how to read data, why not build pipelines using this way, using Jupyter notebooks? We have a lot of flexibility, customization, and we can write Python code. So that's why I use this. But another way is using this designer. It allows you to design pipelines. I will click on cancel for now. I'll click on confirm for now, and I will come back here. But designer is another way for authoring ML pipelines. Automated ML is other way. These are the three ways by which you can create a machine learning pipeline. We are exploring the first one, which is, which is the first one, which is notebook way. Guys, in notebooks, right, there are many possible options. You can see the kernel available here. Wait, let me show you. So you can code in R as well as Python. So some people who are familiar with R, they can also use R and code their program in R. I have always used Python. Okay, so for now, guys, let's develop this project as how a normal ML project is developed, and let's use for fast pace, right? Already written code so that I'm not spending time in showing you how to develop a Python project. I will just borrow the code. Titanic survival prediction Python. And I will borrow the code. Where is, okay. So we have one notebook. I'm opening it and I think it might be out of track, but can we code for deep learning? Yes, you can. You just use deep learning models. Just use deep learning models. Like how I'm going to show you using a normal, machine learning model for this Titanic price prediction, survival prediction. Similarly, use a deep learning model. Cool. So you have all these things you can do. We did head. Similarly, we can do basic feature engineering. Where exactly are feature engineering steps? Yeah. Okay, perfect. These are feature engineering steps. So let me copy the feature engineering steps and paste it here. Cool. And I am dropping these. I am using training data as the variable name. Cool. So let's use that. Test passenger DF. No, we don't need it. So we did these two steps. Then what else? Then we need fill NA with S. Again, I will have this step in my notebook. I'm just copy pasting these codes because I just want to run this as a proper code so that it will generate output and I can show it to you guys. Let's again go back to Machine Learning Studio and let's again also see what exactly it is like. So now it is clear what is Machine Learning Studio and how it looks like. You guys have been familiar with the screen which I'm showing on the screen. Is it cool? How are you liking it so far? How is your experience with Azure platform? Those who are working it, they will like it. It's very powerful. It's very powerful. Again, let me go back and show you what all things you can do. So when you will click on compute, right, you can see the potential of Azure machine learning platform. Just click on compute. Have you ever thought of working on GPUs? Okay, all right, guys. Click on stop after you are done. After you are done, stop your compute. Please, people, it's costly. Again, let me show you the potential, what all things you can do. So I'm commissioning a compute, and you can see from all the possible options what all things are possible. You have, you can ask for a computer with 14 GB RAM, 2 cores, 100 GB storage. You can ask for computers with 16 cores, 64 GB RAM, 128 GB storage. You can ask for 64 GB storage as well. And you can even go for GPUs. Let it load. You can go for 512 GB storage, 32 cores, 256 GB RAM. How many of us have, 256 GB RAM in our machine? No, none of us, right? But when you will do, cores means how many, parallel jobs it can run. More the number of cores, more the number of parallelization that you can do in your program. Yep, yeah, not even in our dreams, but it is possible here. You can commission it, and your entire Python script will run on this compute. So we were running our notebook on a very cheap compute that I commissioned. Even that costed us 0 point something $3 per hour. What was the cost? Again, 4-core compute, 32 GB RAM, and it costed me how much? $0.25 per hour. Yes, exactly. So if you will change to, you even have GPUs, you even have, TPUs here. It's up to you. If you have money, you can, take a compute with a TPU and do whatever you want. Select for all options and keep on scrolling, and you will be like amazed by seeing the potential that you can have. The code here runs amazingly well. Yes, yeah. So here you have 112 GB RAM, high performance compute. You have different kinds of compute as well. You have some computes for memory optimization. You have some computes for compute optimization. You have some computes for high performance and all these things. You have some computes for storage optimization. So where to use what is up to you. You can read about it. So what exactly is storage optimization? Storage optimized VMs, where it is used, what should be the use case, what kind of data you should be storage optimized, what kind of data you should be memory optimized. So I generally use memory optimized as a de facto rule. But if you are a solution architect and you know or you understand these terminologies and you are very crunched on, the overall cost of your project, so you can experiment with it, you can try out. Yeah, this is going to be super fast. Also, your laptop cannot run or handle big data. This can handle. All right, so this is the power of Azure ML, and that's why people use Azure ML for their deployment, because on your local machine you will not have such capabilities. So again, let me go back to this stage, this diagram. All right, so what we were doing, we were loading the data. So data, we uploaded it on the blob store in form of CSV file. We trained the model. Then we have not done training of the model. We are still here. We read it in a CSV file in our notebook. We will do the training, and then we will deploy the model that we will do in the next one. And then we will, leverage Azure ML for the deployment. And what exactly is here? So yeah, let's again get back. So this is ML UI. The notebook is where you can develop your own code, manage the Jupyter notebook, and integrate it directly in the studio. So they are only showing you which file. So again, let me show a slide. So from the current slide. So they are showing you only the default, Jupyter. Yes, exactly. After train funny, we are going to create the pipeline. So this is your default, Jupyter notebook. But you can also edit it in Jupyter by clicking on this 3 sandwich icon and clicking on edit in Jupyter. So also the steps which they skipped in this presentation is creating compute, that is necessary. Another one is designer. I was showing you about designer, right, for drag and drop. So automated ML UI, again, different. In general, right, your overall machine learning architecture encompasses these things. You have Azure storage account, which is blob storage. You have container registry, you can create it. You have a key vault, which is the key access key that, and you have application insights. Then you basically have inside the workspace your data store and your compute targets. We created data store, we also created compute target. Then you have managed stores like your compute instances or compute clusters. So we created a compute cluster too. And finally, at the end, you will end up with assets. What will be your assets? Your assets will be your environment, your experiment, your pipelines, your data sets, your models, your endpoints. We will see all these things later. Okay. We are also using Red Hat in this. Yes, you can have a Red Hat based compute, and you can in compute you can select attached computes, and here you can choose your own compute which has Red Hat installed in it. .pickle is for models. Model is saved in pickle file, or you can also save a pipeline as a pickle file. But here the pipeline which you create in Azure ML, you cannot export it as such. I have never tried exporting a pipeline. Great, guys. So once you log into portal.azure.com, we have created a workspace called Intellipaat demos. I'm going to use the same workspace. Can you guys open this workspace, Intellipaat demos, and click on Launch Studio? So we are in this Azure Machine Learning Studio. What exactly we have inside? We have inside Home. So Home is the first page where you are going to land when you open your Azure Machine Learning Studio. Then we have Author segment where we have notebooks, automated ML, Designer, and then we have some assets. Then we have Compute. So what we are going to do is, so I have already put this to run. But last time I asked you all to stop your compute. Since we are going to start the development now, can you guys start your compute? All you need to do is just click on it and click on start. So for me, it's showing stop now, but for you guys, if you have not started it, it will show start. Can you all start your compute? Say yes after you have started your compute. Perfect, perfect. We all are good. Okay, fine. Now, so I told you, right, there are various ways in which you can author your pipeline. And the best way, which is the way for data scientists, and which is very rarely talked about way. Generally, people don't talk about it because it's difficult. And this is the way which offers you maximum customization in order to build your pipeline. The easiest way, which all the trainers generally teach how to develop Azure ML pipeline, is using Designer. So Designer is basically the drag and drop way or the easiest way to create an Azure ML pipeline. So there are already some few, pre-created or sample pipelines that I can show you, with which you can get a sense of what exactly happens in Designer. So let's create one, very basic already written pipeline, right? Binary classification, customer relationship prediction. Okay, fine. Let's see how exactly is this pipeline looks like in Designer. And this is what exactly, people are going to teach you in any random XYZ class when you will attend their class for creating pipelines. So they will, help you build the same thing, right? Where you have a set of steps and, I can legit walk you through it in 2 minutes to basically explain how you can, create a pipeline using Designer mode on your own for your next use case. So let's use this binary classification customer relationship prediction problem to basically give you an introduction to Designer. I don't use Designer because we know coding, right? You have spent all the time in learning about Python, and you guys want to be a proper MLOps engineer, or maybe a data scientist who is also deploying his or her models. So I will introduce you to the difficult part of authoring a machine learning pipeline, which exactly is the right part, or the notebooks part. So if you learn this, what I'm going to teach you, trust me, you are going to be the rockstar in your team, because you can know the customization or the challenges which is involved or which cannot be solved using Designer. What are these challenges? I will explain you at the end. So here we are at the first step, which is the Designer step. Designer also allows me to author notebooks. So I use Designer and I opened a sample, notebook for explaining how Designer works. So Designer basically functions using different components. So each and every component can perform certain task or certain action. I have component for data, I can use several data which is already, present here and provided by Microsoft. And I have a few components like, I can use add column component to basically create or add a new column to my existing data. I can use add rows component to add a set of rows from an input data set to the end of another data set. Then I have apply mathematical operation if I want to do some kind of a operation, or if I want to do some kind of a SQL transformation. So I will use the corresponding to, drag and drop boxes, and we can go ahead with, creating the entire machine learning pipeline. So here in the binary classification customer relationship prediction pipeline that is already built in Designer as an example to demonstrate Azure ML, what I want you guys to notice is I have two data sets. One is CRM data set shared. Just click on it and you will know more details about what exactly is this. So it's a data set with data name CRM data set shared. Description is CRM data set, and data store is Azure ML global data sets. And relative path is a TSV file, which is tab separated value file, and CRM data set shared. Output is basically a data output, and I can preview the data to you as well. So when I clicked on preview data, it basically shows you what exactly is in this data. You have like a few columns. Wait, let me show you all the columns. There are certain variables, and at the end you have a label. So total 230 columns are present. So it's a big data, and around 50,000 columns are present. So if I see, the variable 100, we are seeing it variable 100, and we are seeing it is like, some values. So upper blue bar shows missing values. So some columns have high missing values, some columns have low missing values, some columns have, numbers, some columns are binary like 0 and 1. So this is how the CRM data is like. CRM dataset shared is like, what I am doing in the second step is I'm cleaning the missing data. How I am importing this? If you want to start, right, you can start by first importing your dataset. So you can import your dataset by using one of the component here that allows you to import dataset. So there will be one component called importing dataset or import data that you can use to import your dataset. The data column, the data tab here basically captures, some of the basic data sets that you can use for learning machine learning. So you can use CRM, you can use movie ratings, IMDb movie titles, weather data set, all these. So we started by data shared. In the second step, we clean the missing data. So what are the parameters we have? The parameters that we are using is, we need to clean the columns. For cleaning the columns, we are using minimum missing value ratio as 0.0, maximum missing value is 1, cleaning mode is customer substitution mode, replacement value is 0. So wherever I have missing data in my data set, I'm replacing it with 0. So cleaning missing data, where exactly is it seen? So just go here and search for clean and press enter. See, there is a component called cleaning missing data, right? So when you will drag this component in this workflow, you can see this component is imported. And this component basically has 3 endpoints. This first endpoint takes in a data set. So you need to start with a data set, point it to here. Then you get 2 outputs. What are these outputs? So when I select here, it basically returned the clean data set. I have generally 2 endpoints. One is the transformation which I want to apply. Second is clean the data set. So when I click on or double tap on this, I can basically see that it gives me an option to, to fill the values in these in these fields or drop downs. So these fields basically are what are columns I want to clean. So when I will attach it to the data which I have, I can start seeing this field populated with the columns that I want to clean. Wait. So basically the point which I want to demonstrate is all these, designer-based customization or pipeline development that you want to do are very drag and drop based or very simple or very trivial. It's good for people who don't know, machine learning properly or data science properly, and who want to get started with building pipelines using already prepared set of rules which they want to play with. So I connected the CRM dataset shared with the cleaning missing data component, which I just dragged from, from the list of components. When I click on it now, I am going to edit column. And here I'm going to see column names, and I can input the column name. I I showed you the data preview, right? It basically had variables from 0 to 230. So I can choose which column variable I want to select. I can choose variable 1, then I can click on plus, and I can include, I can either choose all columns, or I can be specific about column names, or all feature, all label, all scores. So just, various ways by which you can clean. Then you can choose from other option what should be the cleaning mode type, replace with mean, replace with median, replace with mode, whatever input, basic data cleaning steps that you generally know is allowed in this cleaning step, already, built for you. I don't want to have this step in my pipeline. I don't want to touch the pipeline. So I just used it for demonstrating how basically components function to you guys and deleted it. Are you guys able to follow till now? Perfect. So this designer is what you are going to learn when you search how to build an Azure ML pipeline. Trust me, it's a very trivial way of building a pipeline. It works, but it doesn't give you customization. You cannot basically use the power of Azure when you build, pipeline with designer. So how exactly we are going to build pipeline? We are going to author a pipeline in Notebook using proper Python SDK. This Python SDK is called Azure ML Python SDK. So if you guys wanna have a sneak peek, so this is Azure Machine Learning SDK for Python. The docs for Microsoft is going to be the place where you can see the documentation and read about what all classes, methods, and functionalities are provided by Azure Machine Learning Python SDK. So basically all the components, workspace, experiments, runs, models, everything is explained here. I'm going to talk about it in the coming slide as well. But first, read how a pipeline is authored using Designer. Cool. So the first step was to get the data set. So I'm currently using two data set. One is my default CRM data set shared. And here I am cleaning it for missing values. And what was my cleaning step? I was replacing missing value with 0, as I showed you in the pipeline. Then I pass the output to another place or another step called add column step. Remember last time I showed you there was a step called add column. So that column is also present. So somebody just dragged it and used it to add one column from another data set called CRM churn label shared. So basically in the project, what was provided was CRM dataset. And if a customer churned or not, its label was coming from another table, maybe another SQL, table or whatever table, which captured against those customer if he churned or not, that information. So I am basically borrowing the labels which was present in the churn labels shared dataset, and I'm adding the label column to CRM dataset shared using add column step. So if I click on add column step, I basically see that it generates the output by default setting, and there is no target, no node information. It will just add column, which is all the values that was present in CRM churn label shared set. Let me show you how exactly it looks like. So it's a data again. I will go to output and I will click on C. So there will be only one column, whether he churned or not. So -1 means he didn't churn, +1 means he churned. So I just added this column using add column step, and I went ahead with my pipeline. So how exactly is the general machine learning workflow? If you guys remember, a general machine learning workflow includes loading the dataset, cleaning the dataset, transforming the dataset, fitting a model, scoring and evaluating the model, and deploy model to interface into inference compute. We need to create inference cluster to apply this model to new dataset, right? No, you can run within the same cluster only. So create one cluster, deploy your entire pipeline and all these steps within the same cluster. So designer, one limitation why I say people don't use designer is it has a limitation. It can only be deployed on a single compute or single cluster. You cannot have each step within the pipeline perfect. Cool. Alrighty, so proceeding next, I will be running this add column also in my compute cluster, not in inference cluster. Let's see how exactly we are going to see the flow. Then we are splitting the data. So again, this is another machine learning step in which we use 70/30 to split the data. Again, it is a component which you can borrow by just searching here, and it's called split data. Just search for it. You will get split data, just drag it. I see it's used for high workload build on AKS. Cool. Let's reach there. Let's reach there. So for general people and for everyone's, without breaking my flow, I'm splitting the data. So once I have split the data, then I have other stages inside it. What exactly? I have one stage regarding, training the model, scoring the model, and returning the output. Other stage is regarding learning or doing, class balancing. So I took the result data set after I have splitted it, and I'm using and I'm passing it for sampling. So for sampling, I use Smote. So in Azure Machine Learning Designer, you have Smote already present as a component. So just search for Smote. This is for unbalanced class classification, and we just use Smote, and we passed it to the flow, to the entire flow, and we connected my dataset output to Smote. Now, what exactly we are doing inside? We are setting the parameter inside Smote. How many nearest neighbors shall be used for generating the synthetic records using Smote technique, and what is the percentage which we are okay with. And once we have balanced the classes using Smote, we are using two class boosted decision trees as the model. So we need to, after we have balanced the data set, we are using a train model step. So train model step again takes the data set, and it takes the model, the untrained model. So for untrained model, we have multiple models available here in designer. We have decision trees. If I search for decision, you can search for decision forest. You can have multi-class decision tree. You have boosted decision tree. You have multi-class boosted decision tree.
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
Split in the 70/30 is in this process? No. There was a separate component where I was splitting the data set into 70/30, not in Smote. So after I have splitted the 70/30, then I'm passing the data to Smote. So the data goes there. Then I dragged a model, which is two class boosted decision tree. And in train model step, I'm basically training the two class boosted decision tree model on the class balance data, which I have already created. Finally, the trained model comes out here. What I do, I use the trained model, and I use another step in machine learning, which is called scoring model step. So I use the score model to evaluate. And finally, I again use the test data set, which was coming outside from this step, the 70/30 step. Your right side is basically your first data frame, which is the training data. Your left side is your test data, which is generated. Smote means oversampling, right? Class balancing technique. There are many ways for class balancing. You can do undersampling, oversampling. Smote is another class balancing technique in which you generate synthetic observations using nearest neighbor technique for the observation that you have. Yeah, you predominantly do an oversampling using k nearest neighbors by generating random, not random, but statistically correct nearest observation similar to the observation that you already have in your data. So finally, I'm scoring the model, and I'm passing the test data. Sorry, the data which I will use for cross-validation again. I use the score data to evaluate the model. And finally, I'm logging the evaluation result, which is present here in the evaluate model component. Smote is used for classification model. Yes, when you have unbalanced classes, you use Smote. So you have output, you have run settings, you have component information, what exactly it does. It evaluates the result of classification or regression model with standard metrics. So finally, evaluate model, and we are done. Now, what exactly we need to do? We need to use the two class boosted decision tree untrained model. Then I again use the train model step to train it on the data set. Then I use the train model, and I'm scoring the model, and I am passing the data set, which is the test data set, the 30% of the data set, and I'm using the evaluate model on the 30% of the data set to again capture the evaluation result. This was my end-to-end pipeline. When I click on submit, this pipeline will get submitted. This pipeline will get submitted. Why it isn't submitting? Do I have anything? apart from this, which I changed. So let's click on validate. Oh, true. Yep. Amazing. Thanks, everyone. Let's save this and let's submit it. So I am selecting an experiment. Let's create a new experiment. Let's name this experiment as designer. And what is this? No, we use underscore. Designer underscore binary class. So once I submit it, then do I want any tag? No, I just submit it on the compute that I have already started. And voila, my job is submitted. All right. So it is preparing a submit. So this exactly is designer, guys. So when you are doing the same thing next time, you just go to home and wait, let me check if it is submitting. Yeah, it is preparing to submit. Once it submits, it will again show me a notification. Till that time, okay, pipeline job, it started. By that time, I explain you how exactly you can create your own new pipeline in designer. This is very basic and very trivial. You use it for your own. So just click on designer, click on new one, and start by data. You can use any data that is here. Go to data tab, click on plus. You can also register your data set, or push in a new data set from your local CSV by clicking on plus. If you have already registered it in your data set, so how we have registered it. So I showed you, right, that we created a data store like demo store. You can reference your data store inside the designer as well. Last time, a quick refresher for everyone who is attending this session for the first time. Can you show pipeline in full screen? I don't see complete pipeline end to end. Okay, let me try doing that. Let me go to pipelines. So this is currently running. This was the pipeline. Let me see if I can show you the pipeline end to end. Alrighty, man. Here, let me navigate through a few code. See, wait, how can I narrow the pipeline? The full screen icon below. Cool. So this is your end-to-end pipeline. What all steps were there? So basically CRM dataset, which was already there in the library that I have used. Then there was a cleaning missing data step, which I used to clean the CRM data. I inputted missing values with zeros. Then there was final labels, which was present in separate dataset. I used it, and I used an add column step to add the labels to my input data. Then there was split data step, which was used for 70-30 training. In the split dataset, I got output, which is the 70% of the data and 30% of the data. 30% is your test data. So what I did is I used the 70% data, which was coming out from the first node or your left node, and I used smooth to balance it. On that balance set, I use two-class boosted decision tree. I train the model, I score the model, and I evaluate the model. Now this evaluated model, or again, untrained model was used here. Two-class decision tree, they both are same. Once I create it in a single workflow, they are same. They are essentially referenced to each other. Then this trained model is again, getting trained on this data set, and it is used for scoring and evaluating the model. Now let's see what exactly we get as the output. The job is still running. We will see what we are. So can we take a simple small CSV file and carry out each step one by one along with you? So that would help us in creating pipeline. Yeah, we can do that. Do you want to invest time in doing this designer, Yogesh, or do you want to do notebooks through notebook step? Your call. I can teach you designer, but that won't be something new. That your call. Okay. Even I would prefer to teach notebooks. Designer is very basic, so I will end up wasting 2 hours teaching you how to drag and drop on a basic data set. So when you use designer, the components are already defined for you by Azure ML, and you cannot do anything outside the component which is already created or already present. But if you actually want to do some real stuff, we need to create everything from scratch in Notebook. No. Notebook. So guys, the terminologies which Azure ML uses, right, are very generic terminologies. Notebook in Azure ML doesn't mean the Jupyter notebook that we have in Python development. By notebook here, they mean a way to author your pipeline using Python code and Azure ML SDK library, which is hosted in a Jupyter Notebook IDE so that you can type your Python codes to build the pipeline. Designer, on the other hand, is another way to author pipeline using already prepared components, which are basically drag and drop steps that is generic to many of the ML workflows. So what exactly happens in an ML workflow? If you guys remember the pipeline that we just deployed, sorry, we are just running, there is essentially a data load step, data cleaning step, then class balancing step if it's a classification problem, and then we have you cannot. There is a way to see code here. Here you can go to job overviews and code, but since you are not using any Python script step, you cannot see the code which is involved in any of the component present here. So as the pipeline will flow, right, the Azure ML will keep on showing what all steps executed properly in green and blue. So currently our pipeline is at its last step, and hence the last step is only in blue, which is evaluating the model from the smart path, and we will get the output. So let's evaluate the output. The output is apparently interesting. We are going to have two model outputs. Let's see and evaluate. Okay, I think it's still running. Meanwhile, let me again go back to notebooks. So designer is one way. You cannot see the code inside the component. You can create components. It's again a preview feature of Azure ML, in which you can create your own custom components, which you can leverage across your workflows, and you can share it with people. Can we see the code behind designer pipeline? It is a JSON file, Pritesh. So if you go to designer, and if you already see the pipeline, let's me go to pipeline. It will be a JSON file which will basically capture all these components information. There is no Python script which will be exposed to you saying that inside this component these all logics were applied, or this decision tree model is called from sklearn library. So you cannot see that. Yeah, it's just like UML diagrams, but these UML diagrams are basically Python scripts which Azure has already created for you and deployed to you so that you can use it as an easy way to build or develop pipelines. But you are very restricted. Like Smart has got many parameters. What all parameters they are exposing in their API for Smart as a component. If you will see the parameters that they are exposing, you only know the label column. You only have Smart percentage, number of nearest neighbor, and random seed. But there are many other things too, which is there in Smart, which you can develop as an independent Python script by calling the smart package in Python, correct? So in order to break past the limitations which Azure is going to give you to handicap you, it's the fastest way to build your pipeline for sure, but it's definitely not the very customizable way to build the pipeline. So our job is complete. Let's see the job overview to basically see what all things happen. So why is it showing running? It should ideally show complete. Give me a second, I'm refreshing it. Yeah, exactly. For actual proper development, we use notebooks because this allows us to run Python scripts and call Python libraries according to the way we want to customize those libraries for our data set. Okay, so let's see what is the job overview. So status is completed. Now in raw JSON, you are going to see what exactly is the code of this. So this is the raw JSON, which captures all these information about the pipeline run. People from DevOps side can read it. Pipeline parameter, there was no parameter which I have given to this pipeline. Output plus logs. So what exactly happened in here? So I see execution log, and I see any error log, I see any output log. You can see these output plus logs here. We will be developing a better pipeline later. Let me, also explain to you. So what all child jobs ran inside? These jobs, to class, clean, missing data, smart, score model, all these ran. Evaluate model, what exactly happened here? So the model evaluation happened here. What exactly was the accuracy? I can click on it and I can see the accuracy metric was captured. It was 93%, AUC value, F1 score. And was there any child job? No. So evaluate model 1 is the step in which we are evaluating the model without, okay, wait, let me again go back to the diagram. Wait. pipelines. So there are two flows, guys. We are one evaluating model with smooth class balancing, and second we are evaluating model without smooth class balancing. Let's see. Come on, man. Come on. Why are you showing it to me again? If possible, can you try to import customer churn dataset, add column, and split the data and show accuracy? Very, very basic. Yeah, I can do that. Even you can do it. Okay, right. But it will waste time. Okay, fine. Let me do that. But wait, let me first complete what I was showing you guys. All right. So here, okay. So what I want to emphasize is how to see evaluation, right? How you exactly evaluate your model using the components. So if I show you, there were two stages for evaluating the model, right? Go back, child jobs. In the child jobs, not an evaluate model. Where exactly is this? Here, in the binary classification and in job overview, I had child jobs. So what all child jobs were there? There was evaluate model 1 and evaluate model. How exactly these two are different? Can somebody answer this? How exactly these two are different? There is one evaluate model and there is another evaluate model underscore 1. These two flows. Yes, exactly. In one flow, I am evaluating the model on the balanced data set. On the other flow, I'm evaluating model on the non-balanced data set. So when I check evaluate model underscore 1, it is basically for the smooth balanced data set. And when I'm using evaluate model, it is without the smooth balanced data set. So let's see what exactly I get in metrics for evaluate model step. What is my accuracy? My accuracy is 92%. So when I use smooth, I'm improving 1 point on accuracy. Exactly, perfect. Smooth is balanced and hence we get better accuracy compared to unbalanced class, which was trained without smooth. You also have other metrics like precision, recall, ROC curve, scored bins, which you can drag and which you can see in this evaluate metrics designer component. So it is going to show you how exactly the graph like, right? And PR curve, all those components that allows you to debug or evaluate. So this is designer. Guys, you can create a very basic or very easy models using designer. The components are already present and you just need to create a workflow like UML diagrams using these components as as the stages in your machine learning workflow. So what all we have in the components, we have already seen a few, but you have 79 different components. Just read through it. You can clean missing data, you can convert to CSV, convert to dataset, you can decision forest regression, you can evaluate model, you can execute an R script, you can execute Python script as well. Using designer, in that Python script you can code your customizations, yada 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 yada, and all the stuff. The proper way of developing pipelines is through notebooks. This is what I use. And when I use notebooks, right, I basically divide my notebook into two parts. One is where I create the Python script, and the space is where I create the pipeline configs. Create new file. Uh, what happened here? Give me a second. Create new file. And here I will call this as pipeline build file. Okay, so do this with me. If you are doing it, create two files, one your Python script file and second your pipeline build file. And guys, this is a pipeline. So what this binary classification thing was, it was a pipeline. This is an end-to-end pipeline. A pipeline is nothing but what? A set of machine learning steps which can be changed or which can be modified. Like we can have a new data coming in, we can have, all the details, all the things captured or demonstrated, yada, 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 yada. Again, let's go back to MLOps slides. So we are familiar with machine learning steps, which generally is loading the data, cleaning the data, transforming the data, fitting a model to your data, scoring and evaluating the model, and then deploying the model to inference compute. What we are going to learn today is machine learning or Azure Machine Learning SDK. What exactly is Azure Machine Learning SDK? Azure Machine Learning SDK is used for training models, either locally or using cloud resources, such as Azure Compute Resources. We can manage the lifecycle of the data used in machine learning experiment, and we can operationalize the trained model by easily deploying them as REST services which can be consumed by any client application. And we can automate the process of provisioning and managing of the compute resources required for the required for the ML experiment. So a lot of customization, which generally designer doesn't offer, we get using Azure Machine Learning SDK. And that's why people use Azure Machine Learning SDK for building their machine learning pipeline. So what exactly was in the pipeline that I made using Designer? The components were already created by Azure, and I was just leveraging those Python codes without even knowing what exactly is the Python code inside that Designer component for my end-to-end task, correct? For me, when I'm building the code using Azure ML SDK, what I am going to do is I can have ways to train model by locally or using cloud resources. I can manage the life cycle of the data used in machine learning experiment by pointing to the data set, and I can put in as a parameter where exactly it needs to read the input file. And I can also output the pipeline as a REST service or a REST API, and I can automate the process of provisioning and manage the compute resource which is required for each stage in the pipeline or for the overall experiment. The SDK which I'm going to use is basically going to have some components which is essential to know in order to build the pipeline. The first and the most important component is your workspace. So workspace is inside a class called Azure ML.core and workspace class. Azure ML.core.workspace, there is a workspace class. This workspace class is the foundational resource in Azure, which is used to create an experiment. And inside the experiment, we specify what this experiment is going to do. That is to train and deploy the machine learning model. What exactly is an experiment? An experiment class is another fundamental Azure class, which represents a collection of model runs or collection of trials, model trials. Say, for example, the experiment which ran before was basically two model trials. Then each model or each run is basically one instance or single trial of the experiment. And a run is the object that is used to monitor the asynchronous execution of a single trial, and it stores the output of the trial, analyzes the result, and access generated artifacts. We are going to see or come back to this statement after I have already built the pipeline to actually make you, be more clear with the differencing between what exactly is a workspace, what exactly is an experiment, what exactly is a run. I will get back to all these segregations and I will retouch on this slide after I have already deployed a model. So hold on with me. So understand this. So your entire Azure machine learning workflow that is built using Python SDK will always have these three components. You will have a workspace, which is your entire, subscription information, which will have information about the computes available, which will have information about the data set available, everything. AWS SageMaker, pretty similar, pretty similar. Experiment is basically using your workspace. You create one particular run or one particular pipeline submit. Inside the pipeline submit, there will be an trigger or one run, which will again be clear when I will explain to you. In the SDK, there is another component called model. So model is basically the model class, which is used for working with Azure ML's representation of machine learning models. Model registration is used to store your version of model, and registered models are identified by names and the versions, and you can call them in your future machine learning workspace and machine learning projects. You have a compute target. Compute target is basically the compute cluster or compute instance on which you deploy your machine learning model. Compute target is often represented by a variety of resources where you can train your machine learning model. It can either be a local machine or a cloud like Azure machine or a remote virtual machine. All these functionalities were provided by Azure machine learning model. What next? We have a run configuration file. So run configuration class is used to configure the compute target and specify its type and size. Then we have a script run config. So script run config is basically for running a Python script, what all parameters should be used. And here we specify the path and the file of the training script. Then we have environment. Environment is basically all the dependencies that your Python component will be calling. Say, for example, the Python libraries that you are going to leverage inside your script. All these needs to be created or loaded in the environment file. It internally makes a Docker image that are used to run the training scripts, and environments are managed and versionized entities that enable reproducibility and portability. So say, for example, next time Python upgrades and you want to have more libraries or more environment variables or environmental dependencies, you can upgrade your environment file. And finally, your pipeline. This is the place where we package everything together. It's called pipeline, capital PIPELI. It's inside the Azure ML.pipeline.co.pipeline method. Sorry, this class is run configuration used find required compute instance resources. No, no. Run configuration is basically for, hey, wait, yeah, run configuration is used to find the specified compute resources. That is true. That is true. So here we specify the compute resources in the run configuration. You are right, Kiran. Then comes what? Then comes the stages. What exactly are the stages? We have data preparation stage, we have training configuration stage, we have deployment stage, we have publishing the pipeline stage. Now, how exactly we get started? The most important component inside my pipeline will be a Python script step. So Python script step is where I will have the Python script, which I'm going to develop right now in front of you, which also has some arguments, which takes in some inputs and returns some output data. And it is basically the place where my Python code will be uh, executed on the data set that I want it to get executed. So this is the main step or the main component. And then we have stages with which we build the pipeline. Let me get started now with development with all these basics in place and ready for comprehending when I'm building the pipeline. I'm starting now. Okay, all right. So guys, I asked you to create two folders. One was Python script and second was, where did I create it? Wait, I created it inside outputs, I guess. Pipeline build. Let me create it outside the output folder. I call it pipeline build.ipipe. Wait a second. Okay, cool. So we have these two files and I am creating the second file as well. All right, so whatever my code is going to do, I'm going to do inside the Python script.ipynb library. And if you remember last time, we already created a code called Titanic threads. Is it available to you guys? Where I have imported the Titanic file. So I'm going to leverage this code and I'm going to build on top of it. So let's copy everything which is here inside the Python script. All right, guys, do you have access to your Titanic threads.ipython notebook? Just keep copy pasting the code from there. I will explain once it is deployed. I will explain what is happening. Copy and paste. Then remember we created a run instance. Then what else was present? Then we had training data. So load till training data. Yeah, you can rename it, but I want to have it handy for future references. Cool. So run the file still here and we will save it as a file. It is already connected to the best compute, which was the name of my compute. Alrighty. So let's build a very basic pipeline which reads the training data from blob store and it basically prints an output. And we will start one by one, like a very basic hand holding exercise, which I'm going to do from you guys. And let's just print what exactly is the row count inside this training data. So how do you print the row count? You print the row count by saying training underscore data dot shape. And you basically want to know the row count using shape 0. So it has 891 records. So just use a print statement saying print. And inside this, I'm going to write str count of records, closing this, count of records in file is colon and space. Cool, fine. What I need to do now is I will be saving this file. So let's save and let me export it. Export this as a Python file. So once I am having this file as python script.py, I am creating it. All right. So now what I have a Python script, which I just built from Jupyter Notebook, and it does nothing. It basically does a bunch of, account validation or credential authorization. Then it basically tells what data store it needs to hit. From the data store, it reads a CSV file called train.csv and just prints the count. Oh, wait, I don't need this print. And I am saving it. Now, I want this as a pipeline. I want to run a pipeline, a Azure machine learning pipeline, which basically performs this step. How I will do it? Let's go back to pipeline build step. All right. In pipeline, oh, I don't want this pipeline build. I want another pipeline build. So let me close this. Titanic Prits.ipynb. I don't need it. I need the pipeline build. Yep, here. Pipeline build.ipynb. Now, for pipeline, how exactly we build the pipeline? So for building the pipeline, we again need to create the workspace. I am specifying the workspace details, and I am sharing the code with people over text. So follow the chat and keep pasting it in your blocks with which you are building the pipeline. We are going to add more to it one by one, and I'm going to explain each and every component too. Then data store, Control A, Control C, and paste it in your block and run the data store. My bad, I need to run the workspace first. Keep running the cell as you build it. What? User exception. Cannot find. Oh, my bad. My bad. Rename it to your data store. What was the name of the data store? Let me go back to data stores. Or wait, it was there in Python script. The name of demo store is the name of the data store. So use this code with the name of the data store that you have created. Control A, Control C.
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
Oh, damn. Okay. Because I'm going to call a Python script step at the end. Okay, guys, just see here how I'm demonstrating, and I'm going to share this code with you. Demo store. Then what I need to do is I need to specify the compute on which the pipeline will run. So I am copying the compute details, and I am renaming the compute to the name of my compute, which is best computer. So I'm calling it best computer, and I am specifying the size of the VM. So for that, I again need to go to compute and copy the size of my VM. What was the size of my VM? Okay, standard E4S V3. So I'm just pasting this standard E4S, pasting it, and I am initializing the compute. So now I have created a compute target variable. Then comes the next step. What exactly is this? Here I am creating a config file. Config file is going to refer to the compute and the environmental dependencies that we need in running the code. Then I am triggering it. Then comes the next stage, which is building the pipeline. So for building the pipeline, I am using a Python script step. My entry point is going to be the Python script, which I am pasting here. And I am renaming the Python script with my file name, which is python underscore script.py. So let's again run this too. Cool. This is my entry point. Then comes next. What exactly is? I am copying another line, which is basically the first block in my pipeline, which is Python script run block. And I am specifying the configuration, which is AML run config, allow reuse is equal to false. I'm going to explain these parameter. I'm first building the Python script step. Just hold on with me if you are getting confused right now what all things I'm doing. I'm going to explain it. Python script steps, pipeline steps, which is I'm going to paste. Then comes the entire pipeline, Control A, Control C, and here I am putting the pipeline steps. And finally, the pipeline is hopefully going to get built. Yeah, perfect. I'm going to tell what is the experiment name, and I'm going to submit the pipeline. Perfect, guys. Alrighty. So before I do anything, let me open edit in Jupyter. Confirm. What? Why exactly it is empty? Give me a second. Save and checkpoint. Not really. It basically fetches the code which I have typed also. This is first time I'm seeing. So it keeps on caching the code that is written and renders it when I edit it in Jupyter. So see, so basically I am at the last step. I am going to name this experiment as first trial of custom pipeline. Cool. And I'm going to submit the pipeline. All right. The moment I click on submit, this is going to run the experiment. You see, created step Python script.py. The step will run and generate new outputs to the pipeline. The link of the pipeline is this. Let's open the link of the pipeline. Now, here you can see the pipeline running and authored using Azure ML. Azure ML notebook. And if you see the stages involved inside this pipeline, there will be only one box, which is the Python script step. This is the job overview. First trial of custom pipeline. This is my experiment. Yeah. What exactly is my flow? Is there any, nested pipelines like how, you were seeing in Designer? No, right? There is only one block, which is the Python script, which is currently running. And I can double tap onto it and I can see overview, what exactly are happening. So for me, I'm interested in knowing output plus logs. So what all things happen inside? There is a log folder that is generated. It is logging all the details around Azure ML execution. So execution logs will have, oh, I'm handling with too many windows. Wait a second. Yeah, so execution logs will have all the details around Azure ML execution, like what all folder was there, job was in progress, it was running, std error log, if there is any error in my code, that should have been printed in the Python console, in the Jupyter console, that gets logged here in std error log. Std output log, again, I'm not sure what exactly it prints. Experiment with it. I never had to face any std output logs. My output gets saved here in user logs. So inside user logs, there is std log, which is basically showing what all things are happening in the code. So I need to go and authenticate my pipeline for it to run properly. So what I'm going to do is I'm going to click on this provided link because it does a AAD authentication. I need to click on this, click enter device login. I again need to go back to my pipeline, which is this pipeline run. And I need to click on the code which needs to be shared for this run to complete. Control C, and I will paste the code. Control V and click on next. It is asking me to log in from the account. So I logged in from my Outlook account with which I created it, and I'm giving it access to Microsoft Azure command line interface. It got authenticated. Now, the moment it got authenticated, I'm going to see the code run more. All these logs are basically generated by Azure ML. It already got here. Yeah, perfect. So it printed things in the std log. What all things it printed? All my print commands, interactive authentication successfully completed. It printed Intellipaat demos. It printed the workspace. It also printed the line which I wanted to execute in the Python script, which is count of records in file. That is 891 records. You guys were able to see the execution. This is how you run or you create a pipeline in Azure Machine Learning, which can run your custom Python code. All right. It referenced the CSV file, which was present in your blob store. It ran Python operations on it, and it was deployed. Now let's deploy this. Let's deploy. My experiment is completed. How exactly I will deploy it? I will, okay, let's move to deployment part later. Let's again see how exactly I build this pipeline and what are the details of this pipeline. So basically, in the pipeline that I built, I leveraged two files. I used a pipeline build.ipython notebook so that I can write how the pipeline should be structured and what should be the flow of the pipeline. And I created a Python script.py, which basically is the main logic which I want to run inside the pipeline. Got it. Now, if you see the pipeline build, so when I developed the Python script.py, what all things I had inside? It was a very basic, Python script that called for libraries like pandas, numpy, and Azure ML libraries like Azure ML Core. And from there, I fetched the classes like Workspace, Dataset, Datastore. Guys, are you able to follow me? Do you want me to go a bit slow? Cool. Okay, perfect. So in Python script.py, I'm basically reading the data from a blob store, and all my code before is going to going to have the ways or the codes that is going to authenticate me to read the pandas, read the CSV file from the blob store that we created last time. In the previous class, we created a blob store called blob store Intellipaat, and we saved it in the data store. Inside the blob store Intellipaat, we had a CSV present in containers, one of the containers, and the name of that container was data for training. And this is what I am referring to in train.csv. So what exactly we did in this Python script? In this Python script, we authenticated ourselves and the blob store and referenced the blob container with the account key so that I can read the data. I created a run variable which is going to get the context and which is going to, used in my Python code to print graphs or to show, uh, show specific details of this particular run, like what was the metric value as I will build and as I will save them in my pipeline output. Now, one key step which this Python script was doing was to read the training data file after authenticating the workspace and setting up a connector between Azure ML and Blob Store, which I have created. Post reading, it printed the count of records in this file. And voila, this pipeline ran properly. This Python script was executed. For building the pipeline, I created a notebook called pipeline build notebook. This pipeline build notebook is what captures all the details around how the pipeline will be built, what all stages will be present in the pipeline, and which stage will leverage which compute cluster or which compute environment. Say, for example, the overall flow of a pipeline script basically starts with authenticating the script to your workspace configuration. You can have two ways to refer file in your work script. Either you can keep the workspace.from_config file empty, or you can pass a config.json file to it. When you have multiple when you have when you have cases where you are using parallel processing in your pipeline using a class in Azure ML called parallel run step, it is always advisable to read config from a standard config.json file, which you can save like this. So go here and go to Intellipaat demos. Here you can, wait, where exactly I can download the configuration? No, I have to go to workspaces. My bad. General funda is save config.json file. Without that also, you can run very well. But many times you will end up with error. In order to solve such errors, I'm trying to help you know the config file, how exactly it is downloaded. Wait, here. No, what the F? Wait, download config file. Yeah, just click on this next to your icon and you can download this config file. You can download the config file and you can save it like this. So do config.json and click on save. Once you have saved config.json file, then what you need to do is you need to upload this in your default directory, which is your users, and there will be a folder next to your name. So just go to upload files and here upload this config.json file. I saved it in desktop, or was it in downloads? I'm not sure, man. Shit, where did I lose config.json file? Oh yeah, it's here. So it's saved to desktop and just click on upload it. The moment you upload it, your file is present in your root directory. So what you need to do is, again, go back to your pipeline step, and from config, just do a ./config.json. Oh, wait, I think this should work fine. Yeah, perfect. So now it is reading your workspace configuration from this config.json file. This is a standard way, or more like a good way or a best practice to refer to your workspace. Sometimes it happens that, because you have dependencies and you are calling multiple pipeline steps from one workspace or another workspace, you want to have a standardized place to load all the configs. So it's good to have a config.json file and reference it. Now, after this, my WS variable will have all the properties of the config, which is inside the config.json file that is read. Again, what you learned how exactly is this root structure created or folder structure created. So when you will log in to notebooks, you will only see users. Inside this, you will see your name, whatever name you have for your Azure account created for you inside users directory. Is it correct? Yes, exactly. Perfect. So what you need to do is you can create a project folder inside which you can keep all your files, or you can just put it randomly after opening. Like here I have codes like cohort analysis, back pipeline, and all the pipeline builds that I'm developing with you. It's a very bad way of indexing. Better way is to create a folder. You can create a folder like saying create new folder, and you can specify and then you can put it there. Or you can leverage, you know uh, we can delve deeper into it. Or you can leverage your root directory, and you can call your root directory and all the codes inside your root directory in your Python script using dot and slash and your file name. So wherever you use dot and slash, you are basically pointing to your root directory inside your folder, where exactly you can have all your CSV files. You can upload your Python scripts, you can upload JSON, whatever. If you create a new folder, so let's say, for example, create new folder, and inside Ankitan, I'm creating a new folder, say, project 1, and I'm creating it. So inside outputs, inside Ankitan, project 1 is created. And inside project 1, if I want to upload config.json, I click on browse, and I again select config.json, and I upload config.json. When I upload config.json here, it goes to projects 1. Now, how exactly I will reference projects 1? I will say, instead of dot, I will say slash project 1 slash config.json. Wait, I need to again start with dot. Yeah, here. So this way, you can index or you can read a file which you have placed here. Say, for example, I have an outputs folder where I have several model pickle files already present. If I want to reference a model in my machine learning pipeline, I'm going to use one of these pickle files, and I can say read underscore model and sklearn dot read model. I forgot the syntax, and I can use dot slash output slash whatever the model name dot pickle. So where exactly this folder gets created? Good question. Are you guys asking me? No, right? So if you go to your data and your data stores, wait, not data. You need to go to your data stores. So there is a default, directory called Workspace Blob Store, which is your default, which you need to click and which you need to open. This is your blob container where all these files that you are uploading is getting saved. So it is referencing this blob container for your directories. Let it open. So all the things that you're doing is referenced here, and you can share it with your team. That's it. This is a container. Why it isn't loading? Yeah, here. In this container, there is Azure ML. Open this. Do you have something inside? No. Wait. Yeah, there is a combined data set which I created before. Data.json, data.schema. Again, go up, go up. In each of the run, I have done few things. Those runs are loaded, add columns. Wait, this is from the previous run. Add column, remember? which we had from the pipeline that is generated. So for each of the pipeline run, there is a YAML file which you can share with your group. There are other dependencies coming in, scored data. Wait, wait. Not this container, man. Which container it will be? My bad. Guys, so basically, if you will go to data store, right, you will see some of the, workspace working directory. Let's try this. No, it's a directory. Artifact store. Is it a directory? No, it's a block container. It's again pointing to Azure ML. Guys, point being, let's not waste time. Point being, you can go to data stores and you can read through the blob stores which is present inside. And inside here, you can see where exactly your codes are getting saved, which then you can, share with your team and they can read and they can also, make any changes. These things are not explained in any, tutorial to you. It's very internal, and when you will keep on trying, you are exploring Azure ML, you automatically get to know where exactly things are present and how it is organized. So Azure's documentation basically explains all these things, but in a very cryptic manner. So it gets a bit tricky to know what you are looking for. But you will, I have my experiment runs here. Okay, for each experiment run, local upload. Yeah, perfect. So inside local upload, dude, come on. This is pipeline build. Yeah, correct. This is my code, pipeline build.ipynb, which I uploaded, right? Cool. So guys, explore this folder. Explore this folder. You can share these paths, new13.ipynb. I did a local upload for this. Then any other upload, any upload that I do, it goes here in all these uploads. Do I have show more? No. Some of these IDs are what you can share with your team. It's in the blob store container. How you can find it? You can find it by going to data sets, and inside data sets, you can go to, inside data store, you can go to each of these stores, which by default Azure ML references to in order to save your files or save your scripts. Okay, let's again get back to notebook. You can share from here the codes with your working team. All right, so what I am doing in my pipeline. Cool. Folks, are you able to follow? All right, let's see what exactly happens with the pipeline building step. First step is you need to call the workspace, which will be, so this pipeline build is a wrapper, but main ML logic, exactly, yes. So this Python pipeline build is a wrapper, and main logic, which I want to use, is in the Python script file. Very true. Perfect. Guys, is everyone clear with this line? The main logic which I want to run, I want to use Python for that logic. And my logic, the logic which I have developed, is present in Python script.py file. And this logic is run as a single step in my pipeline using Python script step. I'm explaining it to you guys. The first stage of building the pipeline is calling the workspace. So I created workspace, I imported workspace and data store. Then the second stage is calling the data store. I'm following it as a best practice. You can chuck this line as well in your future use. The third step is specifying the compute where on which the pipeline will be executed or run. So from here, you need to use compute target, AML compute, and you need to specify your compute name. You need to specify your VM size. If you have multiple names, you can, if you have multiple computes, you can create multiple variables for multiple computes. Say, for example, I can use compute target 2 and I can use compute target 2 later. So let's create compute target 2 and let me name this as compute name 2 and I will call it second best compute. Okay. And I will use compute name 2 to create this compute target 2. So once you have created the compute target, which is on which computer your pipeline will run, then you go and create the run configuration. And I told you your run configuration is basically all the details around what all environment variables the Python code will refer during its runtime. So I want certain libraries. I want Conda packages like Panda, scikit-learn. I want some basic Azure ML SDKs because I'm calling a lot of Azure ML functions inside this Python script step. Remember the Python script which I created? Uh, it had a lot of Python Azure ML functions that I was calling. Wait, what was that? Python script.py. So I need these Azure ML libraries that I have again called in the pipeline. These libraries, Azure ML.core, all these were present in my Python script, right? So I need to have environment variable. I need to have these libraries in the environment. So I create those environment configuration as a run configuration. So I use run configuration, and inside this run configuration environment, AML run configuration, the environment variable, I pass the Conda dependencies. I use Conda dependencies method, sorry, class to create, these Conda dependencies and pass it to the environment. Then what I do, then I create another step, which is called Python script step. So for, modularity in future use, I want this as a, as a way to rename in future. Maybe I can have, a model which is outdated. So I can use Python script 2 that I'm going to do now in the next step of the class. And I created a Python run step, which is basically the main step where the Python script having the logic will run. Now, what goes inside Python script step? It takes in several parameters. What all parameters it takes? Python script step take parameter like what is your script name, the Python script name that you want to run, then any arguments that you want to give to the Python, then on which computer it will be run. So in my workflow, I only had one computer, but what if we created two computers, like say best compute and second best compute? So we can have one step which is running on a powerful compute and another step which is running on a cheap compute, depending on the, the complexity of that step. Say, for example, I'm doing data wrangling. I can run it on a cheap compute, and I am doing model training, which requires GPU. I can run it on a compute that requires GPU. So I have my entire stages divided and it is triggered on different computes. This is something which you cannot do using designer. Will run config can scale? No, it cannot. It cannot. So for scaling, you need to leverage another constructor in Azure ML, which is called parallel run config. No, it's called parallel script step. Good question though. Yeah, parallel run step. So parallel run step is where you can have parallelization, and it will scale your cluster if you are using a compute cluster and you are, building a pipeline with compute clusters. All right, next step. So we have the pipeline created. What are steps in our pipeline? There is only one step, which is this Python script step. And then I call the pipeline library. I'm pointing it to the workspace. I'm providing the steps, which is one step that is the pipeline script step. And then I'm calling the experiment function function to refer to the workspace, and I'm defining the name of the experiment, and I'm using .submit method with pipeline one as the argument that I have already built. And this pipeline one has only one step, which is to run the Python script where my entire logic is present. And what is my Python logic? To read the data frame, which is train.csv from the blob store, and then to print out the count of rows. And I just submitted it. I waited for completion. There it showed me the path with which I can access my pipeline. I opened my pipeline and I authenticated it because I didn't have any automated authentication. So there are ways by which you can have an interactive authentication also as a step in your pipeline. So read about it, try with it next time. I have many more other important things to cover in this class, and you can, you can do the automated authentication using, in-browser authentication class, something like that. And finally, I authenticated by manual code entry. My code ran, and I was able to see the output of my code in where? In this pipeline tracker, there was one place called job overview. When I went to job overview, I selected output plus logs. Inside user log, I got my, wait, what? This is wrong. Am I opening a wrong pipeline? My bad. No, this is the right pipeline. We did see the logs, right? few moments back. So yeah, finally at the end, you are going to see logs, which is where your entire jobs output gets logged. Oh, come on, man. All right, I'm not able to see logs right now. Some bug with Azure ML. And if you will click on code, you can see the Python script.py. What exactly is the code that it has? The code it refers to. Yeah, perfect. You need to double tap on the Python script step to see the logs. So I see the user logs, and std underscore log dot text will basically log all the print statements of my code. That's it, Vaila. We all understood till here. This is how you can build a custom pipeline which will run a Python script where you will have your logic present. Now, once you have built the pipeline, what you need to do is you need to deploy that pipeline. So how you deploy that pipeline? You need to click on publish and then click on create new. Select your pipeline endpoint name. This endpoint name is first custom pipeline. And then you provide some details about the pipeline, whatever you want. And then you click on publish. The moment you created it and you published it, your pipeline endpoint, first custom pipeline, got published. Where you will find once you will log into Azure ML now. You have already deployed a pipeline. This is your deployed pipeline. This you can call using any REST API, any app that uses REST API to make calls to it, and it will, it will take in input parameters if you have given it the ability to take input parameters. Since we have not given such customization, it cannot do such things. But your REST endpoint is generated. Here is your REST endpoint, your pipelines endpoint, which you can call in your other library, sorry, in your code, which is going to submit this pipeline job.
Just a quick info, guys. If you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
This is your pipeline endpoint. You can find all your created pipeline endpoints inside the pipeline. So we just created and we saved it. The experiment name was first trial, and we can open it and we can see the pipeline endpoint. That's it. Here as an endpoints. In endpoints, you can find your pipeline create. You can find your developed pipeline endpoints. What the hell? Why it doesn't come? My bad. Pipeline endpoints. Correct. You can find it here. That's it. Go to pipelines. Instead of pipeline job, select pipeline endpoints. Here is your pipeline endpoint, which you can use. What are the parameters that this pipeline takes? No parameter. But can you create a pipeline which can take parameter, like where is the CSV file that you want to use? If you want to change it to another CSV file, can you do that? All these things are the questions that you might be having. Let's explore it. This is MLOps with Azure ML. Is it good? Are you able to follow, guys? No, currently it is hard-coded for train.csv, but we can refer or we can pass as a parameter the path of the input.csv file, which will be called in that Python script and which will be submitted to this pipeline endpoint as a parameter. Perfect. Okay, folks who all are getting confused, who all are not liking the session, I am covering it and showing the advanced uses, which generally people don't teach because this is complex. But since people don't teach it, it doesn't mean, you won't be needing it. You will be needing it. Making an AML pipeline from designer, you cannot run your own Python code. If you want your own Python code where you have used steps, that you want, to get executed on the data which you are reading, you need to have customization. If you want, each step in your pipeline to use a different compute with different power, you need customization. For the customization, you need to design your code using notebooks. If you want to reference to different input libraries, you need customization. All right. So now you guys are familiar with Azure ML SDK, right? And I'm opening the chat again. Are you guys familiar now with Azure ML SDK? Python, Azure, ML, Python SDK. Are you familiar? You have seen it functioning. Why this authentication? Oh, because I'm not using another library called interactive auth. So you can do browser interactive authentication. I'm not using that. Wait, I need to do a continue. My bad. Azure machine learning interactive authenticator. Setup authentication. Yeah, interactive login authentication class. You can use this interactive login authentication class, and you can use the force is equal to false. So this way it will automatically authenticate your job. So you can use this. I mean, in prod environment, just use interactive authentication class in prod environment. And also in prod environment, you're not going to trigger this code is required. Yes, not in your pipeline build, but in your Python script that you're calling. In your pipeline script. See, when in prod you are going to use this pipeline, you will hit the pipeline or you will invoke that pipeline or you will submit the pipeline using another software. That software, which generally we use in Microsoft, is Azure Data Factory. So Azure Data Factory communicates or integrates with Azure ML. And this Azure Data Factory is what triggers a job in Azure ML. And there is a very famous video as well, which talks about how to execute Azure Machine Learning Service Pipeline in Azure Data Factory. Read about it. It's very important, very good video, which basically talks about creating an end-to-end pipeline, which has data referenced from Azure Data Factory and Azure ML capturing the machine learning model on which that data is on which the model on the data on which the model is executed. So do watch this. Okay, so I got a job completed. Now I'm going to explain it to you guys. Cool. So yeah. So before I do that, let me again get back to my PPT, which is important. Cool. So you all are familiar with Azure ML SDK now. Again, I'm coming back to what I was meaning with all these parameters. So workspace. So when you build your pipeline, you need to tell what exactly are the, what exactly are your credentials and Azure, what is your subscription ID, what is your resource ID, sorry, resource group name, and all the, all your Azure ML workspace name. So you declare it in workspace. So this we initialize in your pipeline as workspace.config file, which was your first step when we created WS. How did we create it? We imported config.json. The second step was, again in the PPT, why it isn't changing? The second step was creating the experiment. So when you create a machine learning pipeline and you create, you basically end up creating experiments for the pipeline. Like each pipeline will have certain experiments inside it. So it is basically all the trials or individual model runs that you basically do in your pipeline. So each and every model runs become one experiment. I can tell you and I can help you understand how or what I mean by each model run and each experiment. Then for within each experiment, there is one run or one run config. So one run essentially takes in a single trial of the experiment. Then finally comes next your model. Your model is the model that you are developing, and your compute target, which is basically the machine or the computer on which your entire pipeline and the Python codes present in the pipeline is run or is executed. Post that comes run configuration. In the pipeline that we have built, we have compute target already created. This is how you create compute target. Then comes run configuration. It is basically all the environment variables. Say for example, you want to use a smart library or a forecasting library, and you want to call that library inside your Python script, which is packaged here. So in your Python script, while developing, you created a syntax that referred to, say, out of the box forecasting library, say profit by Facebook. So in your Python script, you have profit code. but that library also needs to be present in your environment, right? So you can use a conda package, and here just put a comma and type profit. This way, profit library will be loaded. There will be a pip install and profit will be installed and saved in the Docker environment in which your Python code will run. Control Z, making it easy for now. Then comes your Python script. So when you build your pipeline, you can build your pipeline as multiple Python scripts placed next to each other. In one of your Python script, you can have data wrangling step. In another Python script, you can have your training and model training step. In your final pipeline, you can have your model testing step. There can be ways by which you can move data between one of your pipeline to another stage of your pipeline. That is like having a temporary data set which flows from one of the pipeline step to another pipeline step. Or you can have a pipeline step which basically takes an input, different data, set names, and run the pipeline run the pipeline step on the same data step on the different data set. What do I mean by it? Let me make it clear by drawing a flow diagram. Again, I'm opening the PPT slide, creating a blank slide. Okay, so I need to draw. Okay, perfect. Come on, Ankit, give me this. Amazing. All right, what I mean by this, I'm deleting it. Click to add title. Just give me a second. A typical machine learning workflow basically goes like this. You have a training step, you have a test step. Before training step, you have a data pre-process. So from data pre-process, you go to train and you go to test. Within data pre-process, also given that it's not a one-time thing that you're doing, your pipeline will stay for at least 1 year and your data might shift. It might happen that logic is constant, but you want to train on new data, but train on new data. So when you make the same data preparation step, you want to refer to a new CSV. Now, what is the way? Either you can go to the blob store. In the blob store, for the next build, just upload, wait, where was my blob store? In the blob store Intellipaat, just upload, go to containers and change the data with a new CSV file having the same name. Say, for example, instead of train.csv, put another new train.csv file with new data and keep calling it train.csv in the same path, because your Python script always reads train.csv from this path or this container. It will run the logic on the new data set, but this is a very trivial way, correct? Do people who are already in IT industry, do you align with me? It's a very trivial way. The better way is you pass it as a parameter to your Python script, which you are running in your pipeline. All right. So how you give those Python parameters, how you give the path of the script as a parameter or the name of the data set as a parameter. So that is another thing which you would like to have in your pipeline when you're designing the pipeline. So your logic might change over time. Sorry, your logic may stay constant and you need to change the data set, or you may need a new logic altogether for the pipeline step. So maybe I change the way I do data processing 6 months down the line. Instead of doing a log transformation on, say, a column, I want to use, say, for example, tan transformation on the column, because the way data has changed over time. So what I can do, I can do all these customization using the pipeline that I have built in Azure ML. And it's very simple. So for these, I'm illustrating you what you can do or what you should do. My bad. Dude, come down. Okay, fine. So I'm again opening the pipeline. And in order to change the logic, instead of Python script.py, create Python script underscore change.py. And again, just run this end-to-end pipeline. And voila, in your Python script change.py, instead of doing log transformation, the code, the line where you are doing log of column, just change it to tan of column and save this file as Python script change.py. And you will have a pipeline with all the logic same, except one statement in which you are handling the transformation of the column, and you are good for deployment. This is exactly MLOps. Similarly, what you can do is for the case where you have your data set changing. You can create a Python script, a pipeline, which executes Python script on the same old script. Okay, this is the first scenario. What was the first scenario? Where data changes and I need to train on new data, but logic stays same. So my code will stay same, which is Python script.py. But instead of the old data, which was hard coded, I am using a new parameter called arguments parameter, which will be used in the Python script. And as an argument, I am giving what should be the name of the CSV file on which this code should run. Okay. So how exactly my Python script will interpret what I'm giving as an argument? How will you write a Python script which will take inputs from the pipeline? And how will you create a REST endpoint which fetches input or which gives you a ability to take inputs? Okay, in Azure. This is also something which you guys generally want to know, but if you will find videos online, you will not have videos explaining you this. Alrighty, so let's again go back to our task. So what you need to do is you need to modify your Python script, and you need to use a Python library called argparse. So if you want to take arguments in your Python code or in your Python script, say for example, what should be the name of the data set, what should be the value of the parameter that you are passing as depth of your decision tree, if in case you are calling a decision tree or training a decision tree model, all these parameters need to go in as an argument, right? So the Python script class, which Python script step, which is the class of machine learning, Azure Machine Learning Python SDK that allows you to run a Python script, it has one parameter called arguments, where you specify what argument you will be passing to your Python script. And these provided arguments are referenced inside the Python script using argparse library. The structure in which you need to code your Python script is, and while importing all the libraries, you need to import argparse library. Once you have imported argparse library, then you need to write a few lines. You need to create a parser, which I'm calling from argparse library, and parameter is argument parser. Once I have created parser, then I'm going to add argument, which is my first argument. That is what should be the input data. And I specified the type will be string. And I parsed all the arguments inside this parser using .parse underscore args method, and I saved it in args variable. Now, if you remember the last time when I shared the script, the Python script with you, I have a line called training data is equal to dataset.tabular from delimited path. And instead of path here, I was specifying the name, which was like .train.csv. Now it was hard coding. I don't want this to get hard coded. I want the pipeline step to take argument of what should be the value of input data and then refer it here in the Python script. So instead of passing train.csv inside the Python script, I modularized it to any argument which I'm passing as name input data to the pipeline Python script step. Is it clear, guys? Do you want me to explain it again? People, are you able to follow? Okay. Do you guys want me to explain it again? Hey, everyone, do you want me to explain it again? Do you guys want me? Yes, yes, exactly. Exactly. So when you deploy the pipeline next time, instead of passing train data, just type the name of your next data set, which is test.csv. And you need not hard code it inside your Python script. You pass it as a parameter to your pipeline step. So you use this arguments parameter and you decide what all arguments you want and just use it. Amazing. All right, then comes. Okay, so here I use args.input data, multiple pipeline, train, test, and validation. All right, so you want to understand how you create multiple pipelines. It's easy. You just have one script which will be doing training. You create another script which will be doing testing. So let's create a new file and let's call it .py, and here call it test.py. So in train.py, what you do is you create your code, you create your model and you save your model. And you can save your model to blob store. Exactly like how you read the CSV file, there is a way you can save or write CSV as well to blob store. You guys want to know how exactly you can write back to blob store? Okay, the code snippet with which you can write back to blob store is this. The code snippet with which you can write back to blob store is this. So you need to create a path where you have saved your data. So after you process your code in Python script, you just create a path variable and you declare a path. When I create, this variable, say path temp cohort analysis data project, let me paste it in the Jupyter file, which I can execute. I'm opening a Jupyter file and I'm in a new cell. I am doing this. I am creating a path, Control X, Control V, running it one by one. And for this, I need OS library, import OS, and I am creating the path. First, I'm declaring the path variable. Then I'm using os.make directory, which is os.mkdir command of Python to create a new command. So to create a new directory, which is, I will name it not cohort analysis data project, Intellipaat. Okay, I created the directory temp Intellipaat. So if I will come here in my Ankit Dharma folder, oh wait, it won't be created here. It will be inside each execution of Azure ML. So temp Intellipaat, I created a directory. This is created inside data store, which we provided. Yeah, no, this won't be created inside the data store which you provide, but it will be created in the runtime of your Python script. That means it will reside inside the compute. So in your compute instance, you are creating a temp folder, and inside that temp folder, you are creating Intellipaat. It is not in Azure ML Cloud, but it is inside the compute cluster or compute instance. So I'm using best computer, right? So this best computer will have a temp folder. Yes, it's temporary for reference. That is correct. That is correct. So I created a temp Intellipaat inside my best computer. Then whichever data I want to save, a pandas data frame. Say for example, I want to save training data only, right? After reading, I again want to save training data. So what I will do, after I have created the directory, I will create a local path. And inside the local path, I will use that temp path and I will name it with the CSV name that I want to save. So I am again saving training data back with a new name, training returned.csv. Just save this path. And you need to do a 2_CSV to this path, 2_CSV to the local path. Wait, result cohort view is not the name. The name is training data. This is not a variable. Training underscore data 2_CSV local path. It got uploaded. Sorry, it got saved to the local path or the local reference on your compute. Now you need to write the last statement, which is the data store where you have your blob storage. So our blob storage is in demo store. So I just write demo store. Was it demo store or demo blob store? Demo store. Perfect. And you just need to write a command data store.upload and you provide the path of the directory or the temporary reference in your compute, which is temp/Intellipaat. And that's it. Target path overwrite is equal to true. So this file got uploaded. Now, what was the name of the file? What is the name of the file? training_return.csv. Let's go to blob store. Let's see if this file is present. Data for training. See. Now, if I will refresh this, oh damn, it is asking me to log in again. If I log in, my file, which I have already, wrangled in my Python script, is now pushed training_return.csv. It's clear, guys? So in your pipeline, you are running a Python code, which is this Python script, that takes in your data, does some Python operation on it. And once it is completed, it is writing it back to your data store. That is your blob storage. And you can download the CSV file like how you generally used to download in your local machine. That's it. And you can build different stages like training step, test step, validation step as separate Python scripts. each referring to the final output and kept here. Like, let's call it PyScript run step. All right. Instead of calling PyScript run step, I will call Py training underscore step. Before training, let's call it data wrangling step. And I have a Python script, and instead of script name python script.py, I will create a new script which is called data wrangled.py. Data wrangled.py. And I create entry point 2, which I name as training.py. Then I create another entry point 3, which I call as test.py. And you create another entry point called validation, which you call entry point 4 is equal to validation.py. All right. Now, each of these script you need to create in Azure ML inside your project. So what was the name of my project? Was there any name to our project? We called it project 1. So in this project 1, I can have all these scripts or create new files. Say, for example, I can have training.ipynb. Later, I will save it as a Python data frame. I can develop all the training, code inside the Jupyter environment in Jupyter IDE, read the file from the blob store, then do training of the model and submitting it. Then I can have a new file, which was for testing. So I can create test.ipynb, and I can have multiple Python script steps created. This is one. I can have Python script step. I call it Python training step. And instead of here, I use entry point 2, and arguments will change. I can decide the arguments which I want to give in the script. Then I can similarly create Python test step, and I can use entry point 3. And finally, in my pipeline steps variable, I can have all these individual steps that should make the pipeline. I can write Python data wrangling step followed by Python training step, which will read another script. Then I will have Python test step. And finally, I can have Python, oh my bad. And finally, I can have Python validation step, similarly as a block, which will be referring the validation code. Are you guys clear? Now your pipeline will have 4 boxes. Others, are you clear? All right, nice. So this is how you can create multiple scripts. And what I did was I explained to you how you can have a pipeline which can take an input parameter. So what is different when you make a pipeline which takes input parameter? Remember the last pipeline which I made? So I will show you the old pipeline. This was our pipeline. This was our experiment name. I kept the same experiment name, so my bad. So there were 2 execution. This execution happened, and here there was no parameter. Yes, we can do. You can refer to the data. See, so there was no parameter. If I go here, what was the parameter? Overview. Did it take any parameter? No, right? In this job, there was no parameter. But when you give an argument to the pipeline and create a new pipeline for the argument, then in the parameter or in the pipeline that you have deployed, the endpoint that you have deployed, you get to see your parameter. Arguments use structured arguments. And if you will see inside the overview, you can see what parameter has been given to it. Where is it? Pipeline parameters. Oh, come on. Am I opening the right pipeline? Just a second. Yeah, here. Yep. Inside the child job, argument is input data, which I passed as train.csv. So this way, if you will deploy this pipeline endpoint, you can use or you can submit the value of the argument to your pipeline step. Yeah, let me show you an example of how we can add 2 steps, create a pipeline with 2 steps. All right, so for that, I already have Python script created for you because I knew that while teaching, I will run out of time. So I have a code called new13.py. All right. So here in this code, I am creating a pipeline which is performing multiple model training. So I'm editing it Jupyter, and guys, I will be demoing it to you all. So just follow what I am saying, right? And in this, what I'm going to do is I am connecting to the workspace and creating an experiment. I'm loading the data and training a scikit-learn model. Let me zoom a bit. I'm loading the data and training a scikit-learn model. Then I'm viewing the training results in the portal. I'm choosing the best model. I'm registering the best model to my workspace. Then I'm creating a scoring script for the web service. Then I'm creating an Docker environment. Then I'm deploying the model to ACI, and I'm testing the deployed model using HTTP web service endpoint. All these things I'm using in this or I'm doing in this script. First thing first, we need to create the workspace. So that is something that we all know. Then I'm using an experiment. Let's call it diabetes experiment and in class. All right, because I'm showing it to you in class. We run this. Then inside this, I'm loading a data set, which is diabetes data set, which Azure ML by default provides. So no need to read the CSV, but you can read a CSV too. And I'm doing a test range split step. So this I'm doing in this library, sorry, in the pipeline notebook only. So unlike what you have studied so far, like create a separate pipeline script, create a separate Python script, I'm doing everything in one single script, which is acting as both pipeline deployment script at the same time your Python script as well. So inside this pipeline script, I'm creating an individual script for training the model. You guys will see later. So what I'm doing is I am doing the data split step, which is the test train split of scikit-learn, and I am splitting the data. And here, what I'm doing is I have a set of alpha values.
Just a quick info, guys. If you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
Which I want to pass as a parameter to ridge regression that I want to implement on this data set, diabetes data set. And for each run within the experiment, I want to start logging the alpha value. At the same time, what is the fit of the model for that alpha value in the ridge regression? And not just that, I want to compute these things while logging. I want to predict the RMSE and I want to log RMSE. And I want to save the model as well in a new file called outputs file with model name. And in model name, I'm choosing the alpha value for which the model was trained. And then I'm using a joblib library, which is another Python library, just like argparse. Joblib is another library which is used in AML, Python script very frequently. And I'm dumping the value of model with the file name that I have created as a parameter up in the previous line of the code. And then I'm uploading the file and I'm completing the run. So you guys know, right? In your workspace, you have experiment. Within experiment, you have run. This is what I'm doing. I'm starting the experiment inside the workspace. And then for each run with a specific alpha value, I'm logging the model output. All right. So let's run this code. Okay. So I ran the code. The code, because it is running for multiple iterations, 10 iterations, it will take time. What the above code accomplishes, although I've explained, but let me again reiterate. So for each typed alpha hyperparameter, a new run is created within the experiment. These alpha values is logged to different runs. For each run, a ridge regression model is initiated, trained, and used to run prediction. The RMSE value is calculated using mat.square root actuals ytrue and ypred, and I'm logging the RMSE value. Similarly, I am completing the run. The next model is run because I'm putting everything in a for loop, and this way I'm completing the experiment. So experiment is collection of runs. For this experiment, I am having 10 runs with each hyperparameter, and for each run I'm logging and I'm saving the model output. Once the experiment is complete, when this will go green, I will type this cell with experiment variable. And with that, we can view the result in Azure ML portal. Wait for 2 seconds. Doubts so far? Okay, guys, is it completely bouncing ahead? Okay, so this experiment is created. The name of the experiment is Diabetes Experiment in Class. And I'm opening the link to Machine Learning Studio. And here you can see all those 10 runs, each run getting completed, right? But the whole point was I wanted to share the knowledge with you guys so that next time when you do it yourself, you don't feel like, hey, you know what? I don't know what happened. And I don't know Ankit to go back to him and ask, hey, Ankit, have you solved this problem? So see, this is for alpha parameter 1. The RMSE value was 56.61. It got saved, correct? Similarly, another run will have for different alpha parameter. What was the RMSE value? Alpha parameter was 0.4, RMSE value was 56.62. Then another run within the experiment will have, so there will be 10 runs. So first run will be with 0.01. What was the RMSE value? Come on, come on, come on. Metrics will get logged, 56.60. So basically for each of the hyperparameter, we were hitting basically 56 RMSE. But guys, what got clear to you is how can you use run for logging the value? So when you want your pipeline to log any particular value that you are generating in your Python script, you use .log corresponding to your run. So run is basically initiated with experiment and you type .start logging. Okay. And you can also do something. Say, for example, I know diabetes dataset. Let's say diabetes dataset. And I want a graph. All right. So how can I log a graph? So xtrain dot head 5. What exactly this xtrain looks like? Okay, so I want to log a graph of age in each run. So I do run dot plot and wait, there is a run dot log underscore plot. Wait. Run dot log underscore plot. How to log a plot in Azure. So this is what I want, and this is what I want to share with you all. Come on, open dude. Run dot log underscore plot. If I know it right. Yeah, log underscore plot. And here I will run dot log. Next create a run dot log underscore plot. And then I will plot the data, which is x underscore train and hyphen age, age e, was it capital G? Yeah, age e and dot plot, dot plot. So you can call your plot instance and you can use the run variable dot log underscore plot method. If I am right, yeah, log underscore image, my bad. It wasn't log dot plot. It was log underscore image. And now in your outputs, you are going to see the image of or the plot of your xtrain age variable. Let it run. It will again take some time. Oh, okay. Run underscore plot. This is not valid. Okay, let's not run it for so many iterations. Let's run it for only 2 iterations for alpha is equal to 0.1 and alpha is equal to 0.2. We put this. What happened? Oh, it made Azure ML exception. Yeah, so this is not a straightforward age, right? I need to use a hist plot. Import cborn. I need to import cborn library. Import cborn as SNS, and then I need to do SNS dot hist plot. And what was the name? X underscore train age. Let's check. Yeah, perfect. Let's log this image. I am logging this image as it is. Perfect. Let's see if this gets logged. So yeah, so using, oh, again, it is breaking. Invalid parameter. One of the path of the plot is required as, okay, let's see this. Come on, man. Okay, fine. So basically there is a way by which you can log your images as well inside every run. And I'm not sure why exactly it is not working. So there is a way by which you can log your graphs too in the code. Read or research a little about this PLT. No, run.image won't save it. I need to separate it. I need to save it in my Python environment as a PLT variable. And then I used to call the same log.image. Basically, I need to do some tricks. Let me share the trick. Let me share the trick if you guys really want to know. Log.image. Wait, this will go like this. Import plt dot import matplotlib.pyplot as plt, and then I need to do import matplotlib dot. So when you actually start doing or developing Azure ML pipelines, right, the documentation is not straightforward. You need to try it multiple times, and these are the challenges. The exact challenge which you see me facing here is what you will face. There is no one place where you have people answering all the sequences that you have used in building your pipeline. So follow the template in future in this session. Follow that template. This way you will be structuring your pipeline development. And let's try this. I need to code a PLT variable as well. Okay, will it log or will it fail? It logged. Cool, it worked. All right, so I have my experiment ready. I am able to log the output. Yeah. All right, so now let's again go to our experiment and see in the UI, do we have the output graph? And I will also explain what I did. Let's create an experiment. This experiment is already difficult to follow. Experiment 2. Alrighty, cool. I'm running a new experiment just to show you guys how to log an image. So run instance is used to log all the parameters or all your model outputs or intermediary outputs that you want to be displayed in the UI of Azure ML. You can use this for your future, references without individually going inside the Python script and reading the print statement there. You can just see your pipelines run and the output to check which model is the right model, do all the analysis there. So yep, it's got created. And here, let's see if the image is saved. So metric, we logged metric. So for alpha is equal to 0.2. Do I have my graph? No, not here. It should ideally be in output plus logs. And if I click on plot here, this is my graph of training image, which got logged. Come on, open. Okay, fine. I need to download it. It generally shows. I don't know why it doesn't show. Is it any plot? I'll just, oh, it's empty. Cool. I'm missing something. Okay, so I'm creating this PLT object, but I'm not able to refer it to my graph. So there is a way by which you can refer the graph that you want to save. I am missing it right now. But cool, this is all in MLOps. In MLOps with Azure ML. I hope you guys understood how to create a pipeline. You guys understood what all MLOps is. And I was able to share with you all, the steps which it takes to make an Azure ML pipeline.
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job.